Hello, everyone. Welcome back to DApp Mentors. I am Darlington Gospel. Today, I'm excited to walk you through RumbleCourt, an AI-powered courtroom simulator that is going to blow your mind. Imagine having three AI agents, two opposing lawyers, and an impartial judge debating on any case thrown at them in real time with every proceeding permanently recorded on the blockchain. So that's what we're trying to build today. So whether you are a legal professional, testing litigation strategies, preparing for a debate, or just want to see both sides of a tough decision, RumbleCourt makes it happen for you in moments. We built this for an AI agent hackathon, and I'm going to show you exactly how it works. From the multi-agent architecture powered by Open Router to the smart contract on hard hat that makes everything transparent and immutable. So those are the things that we're going to be doing. So if you haven't hit that like and subscribe button yet for this channel so that you won't miss out on our upcoming builds and releases, I think you should do so now. Please hit that like and subscribe button, right? And the notification bell so that more people can see what we're doing here on this channel and people will be blessed. All right, so let's dive into the tutorial, start building. I'll show you the demo next. Hey guys, before we jump into the demo, quick word from our sponsor today. If you're building or testing dApps regularly, you already know the rule. Your private keys are your crypto. One wrong click, one phishing site, and it's game over. That's why I use Tangem. And honestly, it's a hardware wallet I would recommend to any dev on this channel. It's the size of a credit card, no battery, no cables, no screen, just tap your phone via NFC and your transaction signed instantly. The chip is EAL6 certified, the same standard used in biometric passports, co-developed with Samsung. It is IP68 waterproof, comes with a 25-year warranty, and has a perfect zero hack record across millions of cards worldwide. What really set it apart is the recovery system. You get a 2 or 3 card set during setup. The private key is generated directly on the chip and securely cloned to your backup cards through an encrypted NFC tap. Mutual authentication, DeFi human key exchange, fully air gap. Every card in the set is a complete working key. Lose one, the other still works. No seed phrase to write down, no single point of failure. For us builders, it has a wallet connect integration that is seamless. Connect to any DApp across Ethereum, Solana, Polygon, Base, Arbitrum, hundreds of networks. You get a transaction simulation, human readable preview, and a blockade powered scam detection before you ever tap to sign a transaction. Your keys stay completely offline the entire time. The latest update also added multi-account support. Great for keeping your dev wallet separate from your main holdings, plus smart gas and an AI news feed built right in. If you're serious about self-custody, while we keep building together, grab your Tangem set using the affiliate link in the description section. Use my code DAPMentors for 20% off. And right now, they are running a campaign with up to $20 in Bitcoin back with every wallet, plus a yield mode promo where you can earn extra just by holding $100 for 30 days. Every purchase through that link directly supports more tutorials on this channel. So thank you in advance. The link is below. Let's keep your private key safe and keep building. All right, now let's jump into the demo. So this is the application right now, and we're just going to run through it. Just some basic things you should know. It's just the about page, the documentation page. This page only requires that you interact with the smart contract directly, so you don't need it's just a button-based interaction. And of course, you have to connect your wallet, unlike the courtroom, which is the part that we want to really look at. It will enable you to communicate with the smart contract, interact with the smart contract, and do other things using the chat command. And let's connect this. Okay, you can also choose to use that button there. And this is one case that I created. Okay, so I want to create another one. and I think it's still on. I want to use a controversial example on Epstein. So let's use this case. So this is a case here. I'm gonna paste it and filing a new case about Epstein files revelation on this topic, failure to prosecute the prosecutory discretion among the amount to obstruction of justice. So now it's triggering a call for me to create file this case. So yeah, I've just accepted that, and that case has been added here, and you can see that the case has been successfully created or filed in. Now what we need to do is to actually involve do the simulation and see how the case will be argued in the court, because there are about 3 lawyers that are going to be involved in arguing this case, each one of them with their personalities. So we have personalities for the judge, personality for the judge is an LLM, is an agent, the prosecution lawyer is an agent, and the defense lawyer is an agent. So they're going to argue this case coupled with whatever evidence that they have on ground together to come to a conclusion, which the judge will render a verdict at the end of the day. And then we call F2 to save the verdict on the blockchain. I'm going to click, you select a case and then click simulate and watch how it happens. So triggering this starting of case, and the trial will start. Now the judge has already, which is Sarah Williams, has already, is opening the case, and this is the prosecution lawyer also opening their case. The Sarah Williams is the judge, Marcus Alexander Chen is the prosecution lawyer, and Marcos Rodriguez is the defense lawyer, and each one of them are opening their cases now. There is cross-examination between witness calls and so many talks about what happened, concerning Epstein and all that, and they're going to argue that case out. And depending on how the argument goes, the judge will analyze it at the end of the day and see which side is gonna pick, or if there's no clear winner, or it will just not render a verdict. So I'm hoping that a verdict will be rendered in this case. The judge is about to render a verdict now. Okay, and the verdict is not guilty, and I'm going to confirm this case now, and you can see that the case is completed. So after the argument, there's just a lot of back and forth, which is pretty interesting if you go through it and see what is truly happening there. And then after careful review of all evidence presented, including sealed document, witness testimonies, and communication between prosecutors and defense attorney, I find, verdict not guilty. Prosecution failed to prove beyond reasonable doubt that prosecutory discretion amounted to obstruction of justice, while the handling of the Epstein case raised serious concern about victim rights and prosecutory judgment. The evidence does not establish that prosecutors acted with corrupt intent or violated specific obstruction status. The broad discretion afforded to prosecutors in charging decisions, combined with at the end of the day, it was not guilty. So this is basically what the system, the simulation does. You can also ask a question like, you can be like, can you give me the details on page 2, and then pull that information from the blockchain as well, make it available. All right, so that's the information about it. can also appeal a case if you want to. So, appealing of a case is possible. I'll say, I would like to appeal this too. And then so on, you confirm that an appeal has just filed right there, and so on. So these are some it's very interesting because you can use this whole idea to stimulate your case intent or argue, see from two perspectives, like the way the lawyers they were arguing, you can be able to see the various perspectives in making decision, and even like provide some kind of a simulation or some kind of a sandbox for you to test out how a matter will go. This is very useful for people that do debate or case that will soon go for a court, and helpful for the legal profession, and helps you to think clearer from two perspectives and all that. So that is what we're doing in this particular uh, session, or in this particular build. All right, so let me just run you in through the architecture of this particular application. So this is basically the system, design. So for the front end, we are using basically to have a landing page, a courtroom simulation, a documentary page, where you can play with the smart contract, and then an about page. We have key components, which include the ability to a component for simulation, handling simulation for case history sidebar, just a sidebar, and the terminal message. Okay, so we have, this is the home page, like you see here, home landing page, the courtroom. We've not yet, okay, we can go to the courtroom. So this is the courtroom right here, and then you have the documentary page, which is the documentation page here, and also the about page, which you can see here. So these are the various pages that are part of this application. We have key components, for example, the simulation. This component is found here. This whole, I think this whole place, called the simulation, this whole command, this whole component, this side is the simulation, the courtroom simulation. We have the case sidebar, which is this here, all that belongs to the case sidebar. We have the terminal message, which is where any message we write here drops. So for example, this one terminal message right here. And we have protected routes, which is going to ensure that we are connected before we can access this courtroom page in our application. So this project is built with Next.js, 16, React 19, Tailwind, CSS4, and TypeScript. The reason why we choose Next.js 16 is because it's the latest, and not only that, it comes with the ability of MCP creation by default. So I don't need to install some special package to be able to create, MCP server. This was not possible with what's it called, other older versions. You have to get some specific packages. So these are like context, so we have Courtroom Context, is an essential file in our application that we host a lot of the states of cases, messages, command processes, trial simulation, agent orchestration. So all of those, all of the things that has to do with the status of the application, the processes that are happening within the front end and all that will be handled by this Courtroom Context. So the Courtroom Context contains all the information that you need to know about Courtroom. We also have this wallet context, which gives you information about all the things that are going to be happening in the wallet, whether the wallet is currently connected or disconnected, which network is it connected to, and all of those information so are captured within this wallet. This is including the wallet address that is currently connected. So anything wallet is that context, React context that you're going to find it. We have for API calls, we have OPIC. I'm not going to be dealing with this because this project was from, you know, it was from, a hackathon I was doing. You understand that? And I decided to convert it into a teaching, uh, a teaching material for you guys to also participate. So OPIC was a requirement, but in this case, I'm not going to be using it because it's just going to add extra, extra dependencies and work. And I want to reduce work. So this is important for wallet operations. So yeah, we have LLM, integration. We're not using Vercel in this, so this Vercel, but we can replace this with the whole thing that we're doing with Docker. So we use Docker to operate this. So okay, so we don't make use of this, so ignore that. For open router, we make use of it. We're using Trinity model, and it helps we are doing multi-agent debates. So we're going to be using like 3 agents to do a debate, and we also have like a 4th agent for just general, task and general, operation of the courtroom. All right. So, but for debate and simulation, we use 3 different that is different from the main agent that we're going to be running on. And this topic here, we also need to ignore it because we're not going to be using it in this tutorial. And what else do I needed to say? And so most of these, if you want to really enjoy the depth of agent control and all that, I think you should come into Python ecosystem. That is where you have the best of it. So I'm just trying to give you guys in the JavaScript ecosystem a taste of how you can combine this with the blockchain space. And that is one of my passion, to bring about the AI merger with blockchain and making it easy for you to integrate it on your DApp. So those are the things that I feel passionate about. So this is WAGMI, Vim. So all of these are useful for wallet connection. This is Ethers.js for interacting with the smart contract, and then MetaMask for authorizing transactions within that communicates with the smart contract. So the smart contract basically contains case management, evidence storage, verdict recording, and dispute resolution. Okay, and then we have the network, which have had that, not just Polygon, Amoy, had that local development. I'm going to be using that heavy because I just noticed that Polygon, in fact, the whole thing about using public testnet nowadays is that it's very difficult for you to just keep your that is to get free test ethers. Like, it's so constrained, it's so guarded, like it's real money. It isn't even real money, but they are just being, very, very stingy, or very, restrictive about it. Unlike, 2022, 2023, it was just free. So we're using type chains, okay, but we're not using, IPFS maybe for the future and all that. So that is one thing. I also want to show you data flow, okay, how data is flowing in this view. All right, so we have user. For you to understand how this works. So user, you can type in whatever you want to do, like, try a case, filing a case, John Doe charged with breach of contract. So you enter that record, and this context, passes the command, initiates the case, and basically just build it into an agentic action that we either, call a function or process, just answer you as an LLM will. Okay, and then we have parallel calls. These parallel calls are when we're dealing with the different the lawyers. We have this one called the prosecution agent, and we also have another one called the defense agent. So we're using open router agentic trinity model, not Vercel, of course not. So, and then we have dynamic response adaptation to prosecution claims. You understand that? And this OPIC level, we're going to ignore it. But in the full application, it was part of things that I built into it. these logs. And OPIC is basically a library, a provision that enables you to monitor your prompt and the performance of your prompt, make sure that you have the best version of prompt that you are working on. So it helps you to trace error bars, hallucination, and all the whole crazy stuff that comes with writing inaccurate prompts and all that. So it just makes your prompt better if you know how to work with it. So have a judge agent which analyzes both arguments, weighs evidence, delivers reasoned verdict. So and so on. So we have Polygon, Amoy, which is a testnet, but I'm going to be using Haddad majorly in this particular case. So at this point, once it is with this place, we're going to be skipping this step. But once the judge gets all the point of views from the prosecution and the defense, it will make it do the analysis and make decision. Then after that decision, a call will be made to write the verdict that has been issued by this judge agent into the smart contract. And once that happens, it's going to be stored, and messages or the feedback is going to be rendered in the terminal message component and also updated in the case history sidebar. So basically, those are the workflows and on how this particular application operates. Lastly, one of the things I want to show you is the Rumble Court component relationships. So we have wallet integration. A wallet integration is related to blockchain layer. So MetaMask, wallet provider, wrapper, wallet context. These are various files that are part of this project. When I open the project, you'll find all these things. And then we have, for the blockchain, we have polygons as Haddad testnet. We have Solidity contracts. We have WAGMI. These are just external libraries that are going to be very important. And these are Haddad, types that is very important to communicate with the smart contract. So we have another component, which is the Next.js application. Include about 4 pages basically: the home page, the courtroom page, the documentation page, and the about page. So the courtroom page and the doc page, they're going to be interacting with this wallet, and this wallet interacts with this blockchain. So, and also the page interacts with the LLM layer, okay, which is basically open router in our case here. And at the decision of the LLM, it can call one of the functions of this smart contract and carry out any activities. So these are the core components, like we discussed before: the courtroom simulation, the history sidebar, the terminal, and the protected route. Those are very important. And we have DevOps operation libraries for Docker. Docker is very important. I use that to integrate and orchestrate how it's going to be running on Ring server, because I had already deployed this online and this is running on a container. So I had already prepared it in a way that it will work. So these are some other important libraries, which include Moch and Chai for testing. And we wrote an elaborate test for each one of those smart contract functions. And we're using Solidity for this smart contract, for this operation. We are not using Solana, Rust/Anchor. So it's been a while. I discovered that it's been a while that I actually did or said anything about Solidity, so I had to bring it up, especially in the Ethereum virtual machine ecosystem. So this is Lucid for all the icons that we're going to be using, and then React Markdown to render the output and the communication in an easy to understand manner. So these are contexts. I have Courtroom Context, wallet context, like we've already discussed before, and then these two endpoints. This is for future use. This, we're not going to be using it. So basically, we're not going to be using a lot of this endpoint in this case. So that is the architecture, and that is how this application is. So next, we're going to be jumping into the project itself and start working on different codes and all that. So let me run you through the basic structure of this application quickly. They just the Git uh, workflow. This is for deployment purposes. That is if you have like a VPS or so, or a cloud infrastructure, so you can dabble into that. But I'm not going to be jumping that. This is Husky. This will ensure that whenever you are doing any push to your branch or to GitHub, it will run some processes such as checking for type safety and ensuring that the application is building successfully, so you won't ship bugs into the server. This is just specific to Next.js. Server is managed by the app itself, as you have nothing to do with it. And this is app, which contains endpoint pages, the about page, the courtroom page, the documentation page. I've already shown you all of this. And then this API is not super useful right now. And this is the home page. Okay, and artifact is managed by Haddad. So when you compile your smart contract, this is what is generated. This cache is also not within our control. Then this components, these are the various components that makes for this application. I had already previously shared that with you. Have the case history, courtroom simulation, the footer, the header, the protected route, the terminal message, and type, even the WAGMI provider wrapper, which is for the wallet connection and maintenance. We have context, we have that courtroom context and wallet context. We have contract, which is where our Rumble code lies. We're going to be working on it next. And then this deployment is basically holding the record of the the contract address where it is on the chain. Understand? And the deployer, the deployment hash, and the contract address, all those things are stored there or our own usage within the application. So this is these are some libraries like Courtroom MCP Tools. This is the place where we design about 25 tools that is going to be needed or is being used by our application. There's a lot of them. Okay, so a lot of tools here, and so all these tools are going to be used within the chat LLM agent that is responsible for doing so. And then we have this LLM agent. Okay, so let me show you something. When we come to the context courtroom, we have like this here is one of those agents. Okay, this is just an assistant. Okay, this is just the basic assistant in our platform. So this is like the main assistant, and then right here we have about 3 other LLMs. Okay, so this is the prosecution lawyer, this is the agent profiles. So we're using this prosecution lawyer, I'm giving it a name, exchange, and personality, which is aggressive hook, logical, detail oriented, focused on improving, youth, beyond reasonable doubt, confidence, and all that. So these are his personality, all right, and his instructions. This is defense lawyer as well. This is strategic, empathetic, creative, and focused on creating reasonable doubt, skilled at cross-examination and alternative interpretations. Okay, so this is another agent that we design, that we handle defending or an idea. And this is the judge, which is William, based on impartial, wise, analytical, and so on. So these are the various other agents that are part of this operation. So this is basically the debate structure of how things go about, okay, to reach a. Well, we're gonna look into this a lot more, later on. But this is the playbook of the courtroom. This is where you find the playbook right here. All right. So with that said, I'm gonna close this and head back to script. This is just screenshot script. This courtroom the TS, this is just a deployment script that simulates the courtroom experience from a smart contract point of view rather than a an LLM agent point of view. So this is basically for integration testing. So we're using this to test, how this is going to be well integrated into the into the platform. All right. This is a deployment script that helps us to put the contract in the network. Okay, and this is just a seed script that helps us to put some dummy uh, on cases into the contract. So those are the various scripts. We have a blockchain service that is responsible for providing an interface which our MCP is going to be interacting with, and also our documentation page is going to be interacting with. So this gives our application the handlebar to speak or talk to the blockchain smart contract. All right, and this is just a test script that test all the various situation that our smart contract, all the features our smart contract has. This type chain is generated by that none of our business. This here, we're not using this, so I'm going to delete it anyway. So let's leave. So the rest of it is just Docker compose, how you deploy all these things on the web, on a containerized infrastructure. So we have or had that. I actually had to deploy had that to really prove my the deployment, because I noticed that it was becoming very difficult for you to find your hands on free testnet eaters. And I just want to test a smart contract. It's not as if I want the testnet tokens are very are valuable. They are not valuable. They're just a shit coin, right? And then but they are heavily being guarded, protected, and even to the point where you have to have a certain amount of money on that wallet on the mainnet or on Ethereum before they will give you free Ether. So I have to just deploy my own, test test facet, and I was able to test out all the things that I wanted on the internet and all that without needing any one of them to be my, approval. So we have this is for deploying the front end and Next.js. Okay, so this is hard art configuration, right? And so on. So Next.js, you need you see how important this setup is. This is how yours is going to be in order to utilize the power of MCP. So MCP is still experimental on Next.js testing, but it works just great. Okay, I will not say it's experimental, but it's working just fine. So, but you need to activate it using this setup, and we're putting it on as a standalone so that when this application is being built for production purpose, it will be a standalone operation. It will not be as the way it's running on turbo mode here, because previously there were um, some problems with npm packages where someone is injecting some malicious code into some of the packages, that when you install that and it's not on a standalone, it seems to have it seems to be using your application machinery, that is the hardware of your of your machine, to mine a crypto place or so on, so for free. You understand that? So using standalone has a way of protecting that your machine, to make sure that the codes are already bundled in such a way that it cannot go about manipulating your machine. I don't know if I'm making sense, but that is an extra protection layer. And then you have all these other packages that are involved in this. Okay, so the most important one, MetaMask SDK. React, Transact. This AI is very important. So AI is for making communication, that is LLM interaction and all that. Chalk is for, you know, just on the back end operations, okay? To provide some colorful stuff on the terminal. It has JS for communicating, Lucid for React icons, Opic, we're not going to be using it, you know, React, React DOM, React Markdown for presentation of records or information, Vim and WAGMI for wallet integration. These other ones are for basically the same thing. I don't want to go through all of them. Oh, so basically, this is all there is about our application. That is good. So now, if you, I'm going to end this for now, and I'll also end the blockchain service. If you actually uh, pulled or clone this project, you'll be able to see a starter branch, and we need you to jump into that starter branch. We removed quite a lot of things here. Okay. And please, I don't want to skip this part. This is basically the same as my local environment, but this is just an example of the various stuff that we're using. We're using this model, LLM model called Trinity Large Preview, for all our agentic tasks. So because it is free and I'm using open router, so I'm not paying for LLM agents calls. So that's why I'm using that, right? So in the next part of this video, we're going to start jumping into the program and start coding seriously. So we need to start building the smart contract and move from there. Okay, so everything is configured within this application to make it quite easy for you to follow along. You don't need to touch any other place. You just need to be in this starter folder, and then we can, get on the rest of the project. Okay. Of course, you're going to have to supply all these keys for yourself. All right. So you're going to get an open router key on the internet. You can do that. You won't need this OPIC API because I'm not going to be using that. So I'm going to remove this. So don't bother about this. And this had that. We're just going to use the local host. Okay. Local host. All right. So we're using our local host. And the private key is not going to be very necessary. The only thing that you need to add here is this key. So just go and get that key and the rest can stay the same. Except you want to be a genius, you can try other LLM agents, but I found this to be more capable one in a free tier. All right, so with that said, first thing I want to do is to create a new file. I want to call it Rumblecode, but I want to put it on the contract folder, and I want to say Rumblecode dot so for Solidity. It's quite funny, but this would have been perfect if it is Solana dot so. You understand? But it's still great for Solidity. And this is the first time that I'm writing a Solidity code for a very long time. I've not been writing Solidity. I've been focused on Solana, Anchor, Rust ecosystem, but let's come back. So I'm going to drop this. I'm going to paste most of the code, but to be something that you can follow. This is basically specifies, you're using Solidity version 0.8.19 or higher, but below 0.9 version. So we're just making sure that we spell that very loudly, okay? And we're using MIT as the license. All right, so we're going to drop a title and a description of what this project is about. The title of this project is Rumblecode, and the description is a minimal AI-driven courtroom simulator with on-chain trial recording, records, record case submission, trial outcomes, and maintain transparency. So basically, that is what it is. And course, this is going to be the body of the function. This is where we write the rest of the code. Okay. All right. So what first we want to do? We want to bring in all the enums. All right. And I'm going to show you what this enum. We're going to have enum. Let me just do this. The first enum one to bring in is this case enums. So what is an enum? If in case you don't know, let me just do a quick reminder. An enum, enums are custom types. There are different types of values, of data types. We have integers, unsigned integers, strings and all that. So, but for enum, it's a custom type with fixed set of values. So, like this is going to be very useful for something like multiple choice question, or multiple choice options. You get that? So we have enums that range from 0 to infinity. So this is case status. These are the various case status that we're going to have: pending, in trial, completed, and appeal case. So these are the various enum situations that we're going to have for case status. Also going to have another one for verdict status or verdict type. So a verdict can either be guilty, not guilty, settlement, or dismissed. So, but most of the time we're going to be looking at working with this guilty and not guilty. All right, so those are the enums that we're going to be using in this application. We're also going to be dealing with struct. Struct are also custom data types as well, that groups related data together. So this is it's an umbrella that has multifaceted data types in it, something like this. But I'm going to paste this ones myself here, and that includes, okay, so I have struct, and this struct include a case. A structure for a struct is a short form for structure. For a case includes the the case ID, the plaintiff, which is just the Ethereum address of the person that is filing the case, right? Title, the evidence hash, which is just an IPF hash pointing to evidence document, or a description. You understand that you can also IPFS hash or description, okay, pointing to the evidence of the document. So, and then this file, that this is the time and all that, and the case status, which could either be pending, trial, and all that. So that is what we have here, and that is for structures. And after structure, we need some state variables, all right, that will help us in maintaining some information in the blockchain. This is for persistence. If we want to make sure that stuff stays on the blockchain forever, then we're going to need state variables. And these state variables include things like mapping, all right? So let's bring in the map. For this map, this map, basically what it does is we have all the cases, and all the cases are living in these maps. And this maps a case ID to a particular case. The case ID will be in unsigned integer to a specific case. So that is like a dictionary lookup, okay? So it's like a dictionary table where I supply the case ID, like say case one, and then it just returns me the record of case one. All right. So I'm going to also have another one for verdict, that maps the case ID to its verdict, right? And I thought I supplied the structure of a verdict. I need to do that here. And a verdict has a structure of this. Okay, so verdict has a case ID because it belongs to a case, a verdict type, which could either be guilty, not guilty, and all that, and a reason, reasoning. So this is what the judge we put in as the reason for the verdict. All right, timestamp is final if this verdict cannot be changed. Okay, so if it is final, then it is final. It cannot be appealed. I guess that is the situation here. So once we get that, we also need some other mappings. We want to map an address to user cases. So if we want to find all the case that belongs to a user, we use their address and map to an array of the case IDs. Okay, and that those are for mappings, and we also have um, another another case property called next case ID. Next case ID will be an ID that is a counter for generating unique case IDs starting from 1 to infinity. All right, we also need to know who the owner of the smart contract is. So this will be the deployer of the smart contract. Now, with that done for those, what's it called? Those state variables, we want some events. Okay, events are basically logged on the blockchain and can be listened to by external apps. So it's a log that can be listened to so that external app, whenever that log or that trigger is observed, they can respond to it. It's almost like a webhook or something. So that is what events they do. Okay, they provide extra information on the chain concerning the smart contract activities, right? So one of the events I want to log now is called case file. So whenever a case is filed, this event should trigger and it should log off this following information. It should log off the case ID, which is the index. That is what you use in tracking each case. And the case address is also an index. You use it to track the case, and then the case title. So we need those things. We also want another event that is called trial started. So this is going to be emitted whenever a trial begins, right? And then we also want another one called verdict recorded. So whenever a verdict is recorded on chain, this should trigger, right? So the case ID, the verdict type, if it is final or not. Because if it is final, I don't think you wouldn't be able to now appeal it. All right. And also need another event. This one is going to be called case appeal. So whenever you appeal a case, this is going to be what fired. Fantastic. Now we need a modifier. Okay, this is why I like Solidity. It just breaks down concepts. It's not difficult. It's not like Rust that I need to break things down. Although there are situations where I will have to break the script into multiple places. But with this, this is very good, beginner friendly, perfect if you're beginning your journey as a smart contract developer. Okay, so even modifiers are, the modifiers add reusable conditions / check to function. So if you want to add some reusable checks to functions, then you need a modifier. If you want to add reusable conditions to function, you use modifier. So those are one of the benefits of modifiers. So I'm going to use this modifier called owner only, or only owner. So it's used to ensure that only the owner of the smart contract can operate or work with this, and can call this function. So whenever this modifier, is added to a function, we've not yet added it. This is what is going to be enforcing. It's going to enforce that the sender or the caller is equal to the owner or the deployer of the smart contract. Okay. So also need another modifier. I'm going to call this one um, case exists. So this, if this is used to check if the case ID is greater than 0, yes, that means it. And then the case is within the existence range, because if it's not within this next case ID, if it's not below it, that means that case does not exist. All right. And then you should just flag this by saying that case does not exist. Very important. Now that we have all those things done, we need a constructor. A constructor is a function that runs once within the lifespan of that contract. So a constructor is an inbuilt function, runs once within the lifespan of a smart contract. Okay. So what this constructor does is to set the owner in a standard as the deployer for the smart contract. So that's what it simply does. Now that we have that all set up, we need to now write the core functions that pertains to this smart contract. So the first function I want to write is about filing a new case. So I'm just going to put this annotation right here. So file a new case for AI trial simulation. Anyone can call this function to file this case, right? So this is sort of what we want, but I like to take it one step at a time and not load AI promptings, right? So we have this here, and you should know that we're using this call data for title as the place we store the title temporarily, and since they are strings, call data and what's it called, an evidence hash. We're using call data because it's gas efficient for function parameters. So if you're using memory, it will be more costly, and if you use storage, it's the most costly. So you don't want to use storage. So if you're conscious about gas efficiency, then you need to make sure that using call data for strings. And also you should know that this external here is external can only be called outside of the smart contract. Okay, so that is what it does outside the smart contract. Now that we have that, what we want to do is to want to make sure that we grab the case ID. So the case ID, which is one by default, we're going to assign it here, and then immediately we are going to increment it by 1. So this next case ID is now 2 at this time. So that's how we fix that plus plus to it. All right. And this is very important place. You want to set up this, I'm not doing some crazy validations here where we have to test, since this is a simple smart contract, I'm not going to be doing validation to check for, the case title to enforce that they have values. Okay. But, on production level, you have to do all those validations. Okay. So the first thing I want to do in this cases map, in this cases map, I want to put the case inside. Yes, I will say cases, and I want to target this case ID here, right? And I want to say that I want to assign it a new case. Remember, a case, an unsigned integer is mapped to a case. And what does a case comprise? All of these things. All right. So I'm going to say a case here for this case, and then we're going to put in all that we need. Okay. So we need to pass in the case ID. All right. The plaintiff, which is the filer of this case, the title, the evidence hash, the filer, which is block timestamp, which is the current time at the time is the current time or the time which you are actually submitting this case, and then this status, which is the case pending that we're looking for. So now, once that will be created and stored it will be stored on the blockchain permanently, right? And after you do this, you want to add this case. Okay, you want to record this case in that user's cases. So it's a user's case, user cases, which is this map in here. You want to assign this, want to push it, so push this case ID so into it. So it's going to be recorded on that user's record. And at the end of the day, you want to emit or log out the case that has been filed on the terminal. So this is basically it. This is how you file in a case. Very simple, straightforward. Okay, so we've been able to do this. Now let's do the next thing. The next thing we want to do is we want to create a function that will help us to start trials. All right, so that's what this function is going to do. Call it start trials. And in starting a trial, you need case ID, and it's going to be called externally. Okay, and okay, there we go. So this checks. We want to first check that the case exists. So within the smart contract now, we'll be checking that the case exists. Okay. So for we to do that, you say we require that the cases, when you're passing in this case ID, okay, and then you call on that status. Okay, that status should be equal to these cases. Okay, status dot pending, right? So otherwise it should just give you this message. Okay, so this message case must be pending, so we can start trial on a case that is not pending. Okay, so once we do that check, we want to start the trial, and you can basically start trial by calling on this case status. Is how you call it, state status, right? And this is the case status, and just say it's now on trial period, and then you just emit the trial event. Done, right? And that is for starting trial. So for the rest, I'm just going to paste more of it and just explain, because it's not very difficult. Okay, so here we have another function for, this is for recording verdicts, right? So the verdict requires a case ID and a verdict type, and is a reasoning string, and we're using call data because it's more efficient gas wise, and bool, and its final status as well. And this is only callable by the owner of the smart contract. You see, this is okay if you're not, if it's going to be something that you want many people to be able to use, then you can use this owner only, okay, because you want others to be able to use it. So in recording cases, instead, what we want to do, instead we can do something like we can create our own I don't want to complicate this because I already have, so what we can create a modifier ourselves and say is filer. Just put something like this, filer, and filer is basically saying if these I'm gonna call this time, this is gonna be address. I want to say owner. I want to say if MSG, so owner with that. So this is different. So if MSG, the sender, is also, if we want to say, want to call, say, or want to say, or it is is the owner of the platform, then we want to say contract or case owner only. All right, so that is okay. I call it owners only. All right, so this is better. So we can use this, in place of this, right? So that we solve our problems right there. Okay, so here we go. So now that we have this functioning, we want to the case, yeah, it must be the owner only, and the case must exist. So these are the condition, and if it does exist, I also want to make sure that the case is actually on trial, because only trial is, want to make sure that it's actually on trial or has been appealed. You understand that? So if the case has been appealed, we also want to be able to record the verdict again. All right. So if we say, or case appeal, okay, case must be in trial or appeal. All right. So there we go. And then we come here, we record the various information. So we target that specific verdict. We're adding a fresh verdict basically for this ID and the verdict type, the reasoning, the timestamp, and this final notice. And if the case is actually final, they want to say this case, the status is completed. All right. Yeah. Otherwise, it's gonna be left out. This we won't be adding it into the cases. Won't be updating the cases record. Okay, so this is very important there. The case record. Then we'll drop in the notification to inform the chain, the blockchain, that we have done something like this on our smart contract. All right, so I don't know if this is very, I should have increased this so that it will be easier for you to see what I'm doing. Sorry about that. My thoughts on that. So now let us write another core function. This function this time is going to be called appeal case. All right. So once a function appeal case, so only plaintiff can appeal case, and that is cool. But we can use this function, this modifier here, owners only, to to do this. Owners only. I actually made a mistake here. This is supposed to have a parameter, and the parameter is actually the parameter is the case ID or MSG dot sender. Is it MSG dot sender? Should be. Let me look at this again, this function, because this function is not part of my initial plan. So I'm just trying to make sure that I get it right. So now this is an owner. This owner that we're passing here, what we want to do is to say these cases. We want to pass in the case ID. Okay, case ID here. All right. That will be the best way to deal with this ID, and you want to call on the cases you're tracking, the case ID, and you're calling on the plaintiff. This is the address. Okay, calling on the plaintiff is equal to the current sender. You understand that? Okay, and if that is true, or this correct sender, okay, or the owner of the smart contract is equal to the correct sender. So you need those two, either one of these situation happening. So that is a little bit of a change that I have to make here. Make sure I put this correctly. So this is what we're taking in here. Case exists, and the appeal is only the sender as well. So we don't need this to be enforced anymore because we're having that enforced both there. So by this modifier, and then we have this case. We access the case status, and we're expecting that it's already completed. All right. Otherwise, we'll say that it must be completed, and then we'll require that must also be final, and then you then appeal the case and you emit that record. So that is what it does. So we'll have a few function now, which is the view function. These functions are only useful for viewership, for displaying records. Okay, so for viewing a function, first one, and it's free, of course, so that means you don't need to pay for it. It's just going to be a read-only function, so there's no gas cost associated with these functions. So this get the case details, returns it for you, and say get case, you pass in the case ID. It's callable externally. View is very important, you put it there, so it's read-only and does not change the state of the blockchain. So it's only functions that change the state of the blockchain that get get expensive. You understand that the cost it has. So we actually returning a case, but in memory here. Okay, so this returns copy of the data. You understand that? So a copy of the data, that's what is being returned here. So please pay attention to that little detail, and it just returns it, and it's going to be put on the memory right here. So that's one thing you must bear in mind. I will return the detail of a specific case for you, and also want to get the verdict on the case. So this is for verdicts. I don't know why all of this is a bit odd or hard for this. So this is a function. When we compile, if there is any error, we're going to find out and fix it. Okay, so function get verdict, and we get the verdict, we pass in the case ID and checks if the case exists and returns the case. But the first one, make sure that the timestamp, if the timestamp is not equal greater than 0, that means there is no verdict has not been done on that case. Okay, so if verdict has been done, then it returns the verdict. So that's what is happening there. And then you can get all the cases filed by a specific user using this method. Okay, so get all cases, you pass in the user's address. All right, and use this user address, or you can actually, but I think this more dynamic way of doing it. But you can also use msg.sender to in place of this user to grab it. So this returns all the case IDs of a specific user. All right, that's great, and return it here. And we have another function for getting the total number of cases filed. So this way we get total cases returns an unsigned integer. So returns the total number of cases, that is next case ID -1, okay, because that -1 is very important to get the actual number of cases on the platform. And lastly, for the function, we want to get, want to check if a case has a verdict or not. So we use this function to make that check, right? And the case must exist, and verdict, is greater than the timestamp on the verdict is greater than 0. That we, prove to us that that case has been recorded, right? So now that we have all that, I think there's one place here. This function seems to be, how many places do we use it? Let's see. It was used here in starting trial, and we want to modify that place. Okay, so we don't want to start trials this way. We want to start trials using this other one. Okay, this is more robust. This data for either the owner of the platform or the owner of the case that can start a case. Okay, very important. So after that, how many places is this owner only being called again? Is, enforced by this modifier. So it's only one place that is being called. So I'm going to remove this. We don't need it anymore. You can use this tool here. That's good. Great. Now you need to make sure that there is no errors on your application. So how you ensure that is by calling, how that has been configured has some syntax. So if you do that yarn or npx that, that's help. So the help command gives you some important available tasks. The task we are interested in is this compile task that compiles the entire project, building all artifacts. So yeah, you can see that we don't have any artifact right here. So if we do yarn that compile, now you see that we have a problem here. So if I go to this line of code, this is a problem. This particular place needed to have a semicolon and we missed it, so it's affecting this line. So let's run that again. Compile. Okay, it's generated successfully. You can see it generated my artifact and all those things. Fantastic. Even the type chain and all that has been generated all by running this one command. Fantastic. So that means our smart contract is ready for us to go about testing it now. Okay. Now in the next part of this project, we're going to be writing some tests to test out all those functionalities that we've added into our smart contract. So I'm going to see you in the next part of this video. So at this point, we want to test this smart contract, that we had just completed, to ensure that each one of those functions that we wrote are actually doing exactly what we designed them for. So to achieve that, you need to create a new file inside the folder called test/rumblecode.test.ts TypeScript. All right, so let's look through it, and we're going to be using some libraries. We're going to be using Chai. Chai is going to be important for assertions. So all those expect statement that we're going to be writing, is going to be applied or made possible with chai. All right, so outside of chai, we're going to need hard hat. All right, so this would provide the the runtime environment, give us access to that, and we can interact with hard hat. That's why we don't actually have to spin up any blockchain server or deploy a smart contract before we can test it. Like you see, there is no other terminal running. I could just test it without the need of those. We're gonna need some other plugins from that. These plugins are for Ethereum interaction. It has JS for interaction and this matcher. So we're gonna be needing those for interaction. And now we need this type chain or a TypeScript type for the contract, and it is stored in this type chain right here. So this factory and all of that, we need that, but in that type called Rumble code from that type chain. All right, so those are for import. And if you want to start writing tests, you need a main test block, which is what we call this describe. Now this describe is coming from it's going to be where all the test scripts are, all the test cases are going to be put in. All right, it's an umbrella basically, so it's important that it's there, and it's used to group related tests together. So it means even within this describe, you can actually write another describe. So you want to immediately initialize the rumble code and give it a type of that rumble code. Very important. And after we've done that, we want to define some Ethereum accounts that we want to use for the transactions or for the communication, which is this, which is one, we need the owner to put await and return type. Okay, so we'll get signers, and yeah, so we get this account using this syntax. And once we've gotten this three accounts, want a function that we run on every before every test. Okay, this will ensure clean state for tests, all the test cases I'm going to be writing. So I'm going to put this. Okay, so before each test case, want to get the three accounts from hard hat, a local blockchain. And how we do that is by this, get this account. This is destructuring, array destructuring, because when this comes from get signers, it's going to come in array. So we're going to destructure it into these various variables. All right, that's why we define it earlier on here. And after you do that, you want to get the contract factory, which is basically the blueprint, for deploying the smart contract. So you want to get the contract factory. Let's do that right here. So this will be the contract name and the account that we deploy the smart contract. So this process enables this whole thing to be deployed without needing to spin up the blockchain or anything. So this is test driven style of actualizing it. Now we want to deploy a fresh contract instance. So after I had set up this contract factory right here, I want to come here and say this rumble code now. We're going to do await the rumble code factory dot deploy. So this will deploy the smart contract as rumble code. We want to maintain that type right here. So we're ensuring that it sticks to this type. Very important, right? And then you want to make sure that you wait for the deployment to be complete. So that's why we have this await from code dot wait for deployment to complete, right? So those are very important. And if you're wondering how we got this factory, this factory was this is a format, and you just need to supply the name of the contract and the account that you want to be responsible for deployment. Whenever you compile the smart contract, it automatically generates these this factory here, as you can see, and you can see that this is the smart contract. It has all the type definition of every single thing within that smart contract. This is automatically generated, right? So that, and it's needed for doing audio deployment purposes. So now that we have that running, we need to run some tests. So the first test we want to run is deployment based tests. Okay, we want to confirm that our smart contract was deployed successfully and on the network. So, and to test a unit of smart contract or a case in the smart contract, you use what they call it. All right. So it and all of these are asynchronous in nature. So that's why you always have a sync in front of them so that it can be used for waiting and for asynchronous purposes. Okay. Ensure that the script is following the defined pattern, and where data needs to be waited for, it is waited for, so that you get the kind of result that you're looking for. But because if you don't, it's promise based, it's just gonna skip it, and then because the promise is designed to return a little bit later than doing a synchronous, doing it in a flow. So you understand the nature of a sync and await. That's just what I'm trying to communicate. So a unit of test is an it, right? And in this, trying to test for a specific outcome, which is to deploy successfully. So we're trying to find out if this deployment was successful. So we expect, this is where the trick comes in. So we're using this expect now that we've not been using before. We expect that when you wait get address, so trying to get the address of the rumble smart contract, and we know that if it was successful in deployment, it's going to have an address. So we expect it to not equal 0. So if I call on this add and I'm accessing Ethereum.js, the 0 address. So I'm not expecting this to be a 0 address. And if you understand that, so this, if this passes successfully, then it is obvious that the smart contract passed successfully. Okay. So you can decide to run it. I don't know if it will run successfully because of these errors above here. To run it, you have to can use yarn or npx, and you see how that you want to test. Then you want to test that specific script, test/run report.test.ts. So when you run this, you can see that this particular unit of test ran successfully. So I'm not going to be doing this for every one of those tests. So we're going to jump in and we just stick to each block. All right, so let's start the next block. In the next unit of test, we want to say, it should set the correct owner. So we want to check the contract owner, because we have within the smart contract, we had a variable called owner, right? So I want to see, because when you deploy it, is the owner, as you can see from the constructor function, where are you? The owner becomes the deployer of the smart contract. So the owner, we expect that the owner in the smart contract is equal to this owner that we define here. You understand? So when this owner that we define through getting the signers, and that once we also want to test for a situation with the case ID, because at this point we expect case ID to be just one. So we're checking the next case ID, which is something you can find here easily. This case ID at the onset or the deployment of the smart contract, it should be one, and it should not be anything less than that, right? So if we run this test again, see that the three of them passed successfully. Fantastic. So now let's move on to the next set of tests. And this test that we're going to be writing next, this is for case filing test. Right? So want to test situations that will surround you when you are testing, when you're filing a case. So the first test unit that I want to write is that you should file a case successfully. So there shouldn't be an error when you're trying to file in a case. And so to file a case, we're going to invoke the smart contract. So we'll say transaction, because this is going to be an asynchronous operation. So we're going to call on that rumble code, and we want to call on the connect. There's a connect function method there. I want to use this plaintiff one, which is their account number one, right? And want to call this file case function within the smart contract, and the name of the case, and the evidence, just use contract dispute as the name of the case, and then this as the evidence as whatever. Understand? And then once that is successful, it's going to return as a transaction, and we're waiting that we have that we store it here. So we're going to await that transaction to be completed. So this is very important. You're dealing with the blockchain, and the blockchain is not particularly fast as a synchronous, like a synchronous operation, but it's an asynchronous operation. I don't know what I'm, you're getting the difference. You understand? So there's going to be some time lapses. All right. So to verify that that at least one event was emitted after this operation. So how you do that is you call on this receipt, which is after you waited for the transaction, you get the receipt. And this receipt, there is something called a log, and you want to check the length, which is an array, of course. You want to check the length is greater than 0. That means there is an event that got emitted. If you come back to the rumble court function, you find that at the end of that function, there is an emission of an event. So we're testing that to verify that everything went correctly. So if everything went correctly and that passed, all right, we can have more than one expert. In this month, we only have one expert, but now you can test multiple situations that surround that one unit of test that you're trying to, confirm. The next thing you want to do is you want to retrieve all. You want to retrieve the case with ID one, because there's only one case that has been created. So you want to get that case. We have that function from down here that helps you to get a specific case, which is here, get case, and you pass the case ID. All right. So if this also succeeds, you can use that to confirm that everything is working as well. So once we get that case, the next thing you want to do, you want to test, verify, verify everything about that case. So we want to verify one, I will expect this case ID to be equal to 1. Expect this case plaintiff to be equal to this plaintiff.address, the one that created or filed in that case. We expect the title to be what we passed in as title and what we passed in as evidence hash. And then also wanted to the status to be pending, which is 0, right? Because it's an enum, right? So this is very important. Once it passes all this case, we can confirm that the case is filing successfully. Okay, so if I come here and run this again on find out that it's actually passing successfully, great. So, but there are other, situations around that case filing that we want to also test for, and not just um, the case itself being what's it called, being able to filing. There could be some edge cases on situation that you cannot see it. So that's why we're testing. It should increment case ID correctly. So after a case is filed, expect it to increment the case ID correctly. So we're going to file in 2 cases. So that's what we have here. We have case 1, filing case 1, filing case 2. After filing those cases, we expect the counter to become 3, because initially the next case ID, you understand, was 1, and this next case only points to the ID of the next case, right? So we expect it to be 2 after it has created, expect it to be 3 after it has created 2 cases, right? And also want to verify that the total number of cases, you understand that we have a function for that, is 2 and not 3. This function below here, which is get total cases, which is a subtraction of 1 from the next case ID, expect it to be 2 here as well. So that is one of the things we're testing for, right? So you see that you have to test for all of these unique situations around a function, and not just the primary activity of that function. This is going to be very important in your development process. I'm going to be testing for this situation should track user cases correctly. So we're going to create 2 cases as before. Here we use 2 accounts to create cases. Here I have case 1 and case 2 filed in by one person, and then we also want to file a 3rd case by another user. We now have 2 users that have 2 cases and 1 case, 2 cases and 1 case, respectively. So we want to call on a function within the smart contract that will return all the cases of a specific user. So we have get user cases, and you can do that here. Get user cases will return all the IDs of that user, all the case IDs of that user. So we'll grab that for the votes, and after we do that, we want to, by doing expect, we expect that the first this first account should have 2 and this second account should have 1. So that is what is happening here. When it's being returned, it's returned as an array. So we are actually testing arrays here, right? So that's what I'll say length and all that. Solidity has been refined a lot more, Ether.js and long and all that. It's a lot more mature, streamlined and cleaner to test all this. I can only imagine when I started shooting tutorials for Ether.js a couple of years ago. The tests were not very mature like this and all that, but this is very cleaner, very memorable, and easy for people that are coming into the space to easily understand how to write test cases. So now we're verifying the case IDs. All right. remember here returns unit, that is unsigned integers, which will be something like 1 to 3 to infinity. All right, so when we're testing for the ID, the case number 1 should have ID 1, case number 2 should have ID 2, case number 3 should have ID 3. That's what we're testing for right there. Fantastic. So now we've tested for that, to track user cases correctly and the circumstances around what we also need to test for. So now in this group, let's test one more case. Now this case, we want to say should emit case file event. When you actually creating a case, this is a case file, is an event that we want to test for. We want to make sure that it's there, and to do this, expecting that this rumble call.connect, when you connect, you call the file case, and you file a new case. When you file a new case, we expect that new case to emit this event called file case. And not only that, we're expecting that it will have this argument in it. All right, these arguments include the ID, which will be 1, because we think about it, the case ID, the sender or the creator, the filer, and then the case test, the case title. So this is the one that filing and all that. So we are also testing for this situation here. Very clean, very nice. And then we can run all this to verify that everything is working. All right, so you can see, file is case is being filed successfully. Increment of IDs are done correctly. We're tracking users that created each one of those cases correctly, and events are being emitted accordingly. So that is how you test that function and all its parameters. Now I want to test another. I want to write another case, which is for prior management. Okay, so I'm going to break this a bit. Prior management equation. So in trial management, as you want to bring in the describe, you want to bring in a before each. So there's something that we're going to be running inside. So before each one of these tests that is going to be running in this category, we want to have created a test. So this test case, so want to have a test already available. And now that a test is already available, the case, sorry, is already available, want to write a test to successfully start the trial, because we have that function called start trial. So in starting a trial, we call that function and the specific case ID. So we say await rumble code connect this owner. Okay, so this owner does start trial. So now we're verifying that, because of these owners only, both the owner of the smart contract, which is of that case, which is this, and the owner of the smart contract, which is this, can start a trial. So either I use plaintiff one or owner to connect to here, it will just work just fine. So that's why I have, that. So you should take note of that difference. So we start trial, and after we started the trial, we're expecting that the pending should not be, that is, if I get the case data, it should no longer be on pending, but it should be on trial. Remember, when you when you start this, and so this case status should navigate toward in trial. So that's what we're trying to test for here. So we expect the status to be equal to 1, because 1 as an enum is equal to what in trial. So that's the first test that I want to write here to verify that a test can actually be started on trial, right? So we also need another unit of test should emit trial started event, which is a standard stuff here. I will just emit the number. So what is happening here is that you know that before each one of these tests run, it's creating this, is filing this case afresh. So whatever happened here is destroyed when we're running the next test. So it's not going to be an issue at this place. Okay. So we are first of all starting the trial. All right. So when we start the trial for case one, what we also want to emit, want to test that there is an emission of what of this trial started event, and then we also want to test the argument. The argument should be that it, you know, it emitted the case ID, which is in this case one. All right, so that is just what it is. Now I want to write test another contract. Okay, let's test for another situation. So should allow plaintiff to start trials, to start their own trial. Remember, before now, on this only owner will allow only the owner of the smart contract to start trials, but now it has the ability to decide whether the owner or the case owner. So also want to check that case owners can what start trials, which is something similar to this. Okay, except that we're going to have uh, the case owner connecting this time, which is this plaintiff instead of this case owner. So that you should also be able to start trial. And also, we want to do this. We want to say should not allow unrelated party to start trial. So at this point, we are trying to start this trial with another user that did not create that was not the one that filed in this case. So saying start trial, but you're trying to start trial with plaintiff 2. Meanwhile, the creator is plaintiff 1. So want it to be reverted. Okay, we're expecting it to revert with with this message contract or case owner only, which is the standard message that we are broadcasting here when this modifier is violated. All right, so I want to test what happens when that violation happens. Okay, so also want to test another case. Do not start trial for non-pending case. If a case is not pending, you shouldn't start a trial. So we're going to grab I'm going to start a trial. All right, now that we've started that trial, we want that same person to try and start that trial again. So you're trying to start a trial 2 times, and we want this situation to be reverted with a message saying reverted with case must be pending. If you look at the contract and you're trying to start a case that is not in pending mode, you should say what case must be pending. So that's how you test for that. And one more test case on this, which I'm just going to paste here, is this. I want to test for should not start trial for non-existent case. So if a case does not exist, then it should what revert with case does not exist. Like I'm putting in 99. We don't have 999 cases, so that it doesn't exist. So if we come here and we check this case exists, if this modifier condition is not met, it is return. It panics with this message saying case does not exist, right? So these are the various practices that we want to put in place to verify that our smart contract is responding correctly to trial management. Let's test that. All right, all that cases that we created are functioning. Fantastic. Now we are in 13 passing cases. All right, so let's move forward to verdict recording cases. I'm going to close this down. So verdict recording tests. In this verdict recording test, of course, before we even run any test, we want to first start the case or file a case and then start the trial. All right. So unlike here that we only started file the case, but we want to file it and then want to start the trial. So before any other test gonna be running here. All right, so the first thing I want to do is a case I should record verdict successfully. So after a simulation is done by the judges and by an argument is that which is the courtroom simulation is completed, a trigger for verdict recording is required. And when that trigger happens, it submits that case to the blockchain. And these are what happens. Okay. This is how you submit a case. So you connect with the owner or the one that filing to record the verdict. And in recording the verdict, pass in the case ID. Remember, recording verdict, case ID, verdict type, reasoning behind it, and it's final. You know, also you put all those things. And so that's what I have here. So this is the case ID. This is the verdict, which is guilty, is 0. And this is based on overwhelming evidence. This is the reasoning, and the final verdict is for true. Fantastic. So when you've done that, you want to retrieve that case, or you want to get the verdict. Get the verdict by saying rumble code get verdict, pass the case ID. And once you pass the case ID, you want to test for the various situation around it, which is one, case ID must be the same as that one. You know, the verdict type is guilty as was applied here. The reasoning must, you know, be in accordance with this, and this also must correspond with is true. All right, so that is how you test for a verdict that has been successfully submitted. Now, I want to test for another case, which I will just paste. This case is should update state case status when final verdict recorded. Okay, so this is case that we're submitting right here, and this case is not guilty. Okay, and we're verifying that the case status changed to completed, right? Because when a case verdict is submitted, you know, it is recorded to be not completed, and completed has a status of what completed. If I come here, you find that this is where that happens. So if it is final, it's true, it records it as completed, right? So that is one other test I want to do. And another test I want to check for is should not update case status for non-final verdict. So let's say we're saying that if the verdict is not final, the parties reached agreement, the verdict is not final. So, and the status in this case is settlement, then we expect that, you know, the case will still be on trial, you know, and it's not completed, right? So that's why we have this one here. And We also want to test for verdict events. All this is based on the same pattern that we've established. A verdict event, the judge passed a case where the verdict is dismissed. You understand that? And it lack of jurisdiction. Okay, so this case is completed. And then we want to test that, the function of the smart contract emitted an event called verdict recorded, as you can see here. And this it has this argument of 1 3 true. So 1 for case ID, 3 for the verdict, and true for the state of finality. Right? So one or two test for that. I want to test for this situation. Should allow plaintiff to record verdict for their own case. So all this while we've been working on with the owner, all right? So but also want to check the person that created the case if they are able to do some of these operations themselves. So for example, able to record a case, all right, and the verdict, is there. So that is important. And now we also want to test that someone that doesn't have access to this case and not just come and pass the verdict. This plaintiff too is not the owner of that case, so he should not be able to pass verdict or record verdict. Okay, so in cases like this, we want to say contract or case only, on a case owner only. So this is a revert message we're looking for unauthorized users. Now we have another case. This one should not record verdict for non-trial cases. So let's say you file a case, all right, that case is not on trial, it's just pending. Now when it is pending and you're trying to render a verdict, okay, so this is the case ID 2, right, and the verdict is guilty, and this is the reason, and it's true. So it should revert with case must be in trial or appealed, and we can see where that falls in. So cases that are either on trial or appealed or can render a verdict. Otherwise, consider that case must be in trial or appealed. That's great. Now let's write one more test for this category. So this test this time, should check if case has verdict. So the column this has verdict function for case 1, and it should be false by false because verdict has not been passed. Okay, so we're gonna want pass verdict. We don't need to start the trial because right here, trial has already been started. Okay, so we're saying that we just record the verdict and we expect that it has verdict is now equal to true. So those are the various conditions here. Now let's run this test to verify. Great. So this it test passed successfully. All right, and now let's write another test, proof of test for appeal. Okay, so I'm going to close. So we have group of tests for appealing a test. All right, so we're going to move a lot faster because I'm not going to be going through every single line, but something that is more natural. So here we go. We have, before each case, before we test this, before we write the test, before we carry out test underneath it, we want to first file a case, start the trial, render verdict. All right, verdict is there. So from now henceforth, we can be able to appeal a case, because a case must be appealed only if it has been what verdict has been passed. So should appeal case successfully. So we'll run this. Remember that it is this is the one that actually created the case. So we'll call on this appeal case for one, and want to verify that that case has a status of appealed, and that is successful. And want to check case appeal event. Want to check that case is appealing successfully. So in this place, this event must be fired at the end of the day. So we expect that when you appeal a new case, appeal a case ID1, the event case appeal is fired with one argument, as can be seen with one argument here. So, and then want another case, want to say that do not allow unrelated party to appeal. So if you're not the one that filed the case, nor are you the contract owner, you should not be able to appeal such case. So you should revert with contract or case owner only. All right. So that is what is happening here, as plaintiff 2 is intending or attempting to appeal that case. All right. So we have another test case. In this test case, we want to you should allow contract owner to appeal any case. So you can see here, contract owner was not the one that created the case or filed the case. You can see, but he, because of that modifier we created, owners only, it gives him or whatever, the opportunity to appeal that case successfully as well. So that is what that line of code does. And now we have do not appeal non-completed case. So let's say a case was filed, this is another case, and we started a trial for that case. It's 2 in this case, and then we expect that you're trying to appeal this case now, but it failed because this case has not been completed. That means verdict has not been passed, right? And it should return with this message saying case must be completed. As you can see here, case must be completed. So that is one of the things we're testing for. This is a comprehensive test, okay? And now we'll have one more test in that group, right? A little bit lengthy, but the same principle. So we filed another case and we started the trial and we recorded the verdict. Okay, now, but the case is not final when we're recording the verdict. All right, so yes, the case is still in trial and can't be appealed yet. So when you try to appeal that case, you should revert with case must be completed, similar to how this is. So that is another situation or conditions, for that. So that is all the test cases for appealing, a case, So we want to write another test. This test right here is view function test. So test for testing all those view functions. I'm gonna come here and say view functions, and what I'm giving you is a comprehensive way to test and simulate your smart contract and ensure that every aspect of it is working before you even hand it over for integration. You understand that? So one of the things we want to do is to ensure that we have this thing going on. We created two cases from two accounts and started trial for case one and rendered verdict, but case two is still pending. All right, that's the condition here before we even started recording the cases or testing the cases. Sorry. So the first case we want to test here is we want to get the case one data, and we want to test that of course it has all this, belongs to this. So we're just verifying all the fields, you know, correctly, because that is what we expect a view only function, which is a read only function, to return for us. After that, we want to do should get verdict correctly. So this one tests that details are returned correctly, on checks that verdict, are correct. You understand? So we get the verdict of case one and we confirm the details that it is what accurate, as even the reason here is verdict one, and we are testing all that and its final is true just as it is here. Okay, simple. I'm going to test for a case where reverting a revert is necessary. So should revert when getting non-existent case. So if you're trying to get a case, you understand that get a case with can actually see, put a weight in front or inside of it. Anyone? Okay. So we have Rumble called get case. This case does not exist, and we expect it to revert with case does not exist. If you come to the smart contract and this function here, yeah, case must exist. So this function here has that modifier that this is reusable. So basically being used across various functions, that should enforce that rule in the smart contract. Now it's reverting with that. So we tested for that, and we're testing for the situation. This situation, we're saying that should revert when getting verdict for case without verdict. So you're trying to get verdict for case two, all right, that doesn't have verdict rendered yet. So you should revert with no verdict recorded, just as we can see from here when you're trying to get verdict, but it doesn't have a timestamp. That means it has not been recorded. All right, so also have another case on that situation. We're saying that should get total cases correctly, and just hold on, await, and we'll get total cases, to be equal to 2 because 2 cases have been created. And as always expect there, lastly, for this group of tests, one also expect that you would get user cases correctly. That is to say, this case 1 and this case 2, and the cases of the user in case that created the case 1 is 1, and also the same for cases of user for case 2 is 1 as well, because only one case, each one of them created only one case. So at this point you can run this to check out, right? So you can see that these are all the functions and they are all passing successfully. Great. So at this point we just want to write one more group of test cases. This is now called integration test, right? Integration test. Later I'm gonna, if it is still necessary, okay, which I'm teaching you, basically Solidity skills. So So this is a complete workflow and a serve for what I wanted to do later on. So I'm just going to do it here at once. So this is what is going on here. We have a test, which is the life cycle it to handle complete case life cycle. So the step one is to file in the case, right? So we have a case that has been filed, and we're going to get the case, status. We expect it to be on pending, right? So next step, we want to start the trial for that case, and we expect the status to move from pending to trial. Fantastic. After this, we want to record the verdict, okay? And when verdict is recorded, we expect the case to move from, what's it called, in trial to complete. All right, completed. As you can see, this is just the life cycle of it. And then after verdict has been rendered, we can appeal it. Okay, so we expect, when this is called, we expect the case to move toward appeal. So this is just the life cycle of a case. Now that we've written a test for that, also want to write another test for multiple cases simultaneously. So doing this, we'll file multiple cases by different users. We have these users, case ABC by two users, and then we want to start trials for the first two cases only. So these are the first two cases. All right. Now that we've started for the first two cases, we want to record verdict for cases in trials. So all the cases that are in trials, we'll record verdict about them. So the verdict for case one is that it is guilty and verdict A. This one, it is what? Not guilty or verdict B. And they are all true. That is finality of the judgment. And then want to verify the cases, correct state. Okay, so we're gonna do this. Case 1, 2, 3, get the case records. Then after we get case record, we want to confirm their status. So the status of 1, 2 should be complete, and then the case, the status of this last one should be what? Pending. And then we'll verify, verdict existence. All right, so we have verdict for case 1 and 2 to be true, and then verdict for case 3 to be what? False, because it has not been what? Recorded. So basically, this is the very last test in this script, and this is for integration purposes. So let's run that and see. I'm going to run this. Boom. Okay, that was successful, but I made a little mistake. I think look where this is supposed to be classified or be in this category. I'm gonna have to shift this case a little bit upward. All right, fantastic. So I'm gonna put it in that category. That's where it should naturally be. All right, so we have that case now all represented correctly. So at this point, we are confident that the smart contract is doing all that we want it to do correctly, and that is fantastic. So in the next part of this video, we will proceed into writing a blockchain script. Now, this blockchain script is very important because it is by this script that we can be able to interact with the various functions that are part of the smart contract. Oh, sorry, my bad. I'm going to write the deployment script for deploying smart contract into the network, right? So and then ensure that we are actually um, producing the um, the various artifacts and all necessary I components correctly. So I'm going to see you in the next part of this video. All right, so let's write the deployment script now. Okay, so we're going to do that. Create a new file for this script /deploy.ts TypeScript. We have to import some libraries that are going to be very important. So we need that hard runtime environment. Okay, this gives us tools to deploy and interact with, the contract. Okay, so we need that. We need this as well. Okay, similar to this test script, basically, where we had all those. We use those. Okay, we also need iSystem module. This is Node.js module, which lets us read and write files. We're going to be storing some smart contract address and all that information, okay, to our project. Okay, we need to import path. This is also another Node.js module. Okay, this part will help us to build file paths that works on any operating system in case as this project is shared with you. And one thing I want to do first is I want to remove my Git tracking system. Since I'm in this starter branch, I don't want to accidentally mess up this branch setup. So I'm gonna do this. Remove that ref.git. So I'm gonna remove that GitHub thing. Right. Now we don't have any GitHub tracking anything. So great. And let's also grab URL and directory name. These are also important file system modules. So these are utilities for working with ES modules, modern JavaScript module systems. So very important. Fantastic. We have all those things set up. The next thing I want to do is I want to create this file name. This converts the module URL to a regular file path. So this metadata metadata meta.url, converting it to a regular file path. So in case you don't understand what meta, it is something like this. It is this here is something like this. Okay, so this is how it looks, for example. So we're converting it to a proper file, name or file system. So when it's converted, it's going to move from being this to now being this. Understand that? So that is what this conversion process is actually accomplishing here. All right, so after we've done this, we want to grab the directory name. So directory name, pass in the directory name. So the name of this directory, which will be, scripts, of course, because that is where this deploy script is living. All right, so once we get that, we want to define a type. All right, a TypeScript type. So this will help us to catch errors and all of those things. So I'm going to drop it here. All right, so this is deploy information, the network, which blockchain network, localhost, Sequoia, whatever network that you want to. The deploy, which is timestamp, lawyer, a contract address, and the transaction. So we need all those information. So that will really give us information about each deployment that we make. So we want to create a dynamic deployment file that will capture um, the deployment information per network. Okay, so what I mean by that is, this deployment file will be network, which is a string, and then that network will be pegged against this deployment information. So that is what I'm trying to achieve with this. Once we get that together, the next thing we want to do is we want to configure paths, the path of where the deployments are going to be stored. So we have deployment path is equal to this path module dot join, and this is what we're going to be joining the directory name. Okay, just going to paste this, save us time. So the directory name, which is the current directory, which is this script, the path to go up one level, want to get out of this script. First, want to create a folder within the root directory. So, and then into this directory called deployment, it doesn't yet exist. And then a file named rumblecode.json. So this is where we'll save the deployment information, which is this. Okay, so great. And now I want an environment variable. Okay, so the environment, I will want to target an environment. I remember that we have this example here where, of course, there is no environment here, which defaults to local. If there is an environment and you want to specify something like production and standard, then you can actually do so as well. But for this case, we're going to be using just local for production. All right. So once we select the environment that we want to create this thing on, we'll see a sync. We want to create a main function now. All right. This is where we'll do all the operation. This async always makes us to have the ability to await a promise to be actualized. All right. So first thing I want to do to print is want to get the network and the deployer's information. How you get it is the hard hat environment, called the network, and then you call the get the network. So that is how you get the network name. So which could be hard hat, localhost, whatever network that you want to deploy to. Okay. Once you get the network, okay, and then which could be I'm gonna put this here for you, be any one of these or even more, and the network that we specify, they are all here. Okay, I'm just going to run you through this. Okay, so this is basically the hard hat configuration. This is the Solidity version that is going to be using, and this Solidity version is what version 0.8.19. Uses optimizer, is enabled and runs. Okay, this is optimizer to make sure that it is streamlined, it is optimized, and reduce the contract size and all of those optimization techniques on that the compiler will execute during compilation. And this is network. All right, the network that we define are two localhosts and Polygon Amoy. Now, this Polygon Amoy, I was not able to get test ether, so I'm not going to be using it either because there's no test ether for me to do anything about it. So we need an RPC URL, which you can, if you have a custom one, you can put it in the environment variable and reference it here, or it will default to this one, which is the default add look network endpoint. Okay, and then this is the chain ID for look had um, environment, blockchain environment. And this is the timeout to be 6,000, sorry, 60,000. That is timeout, and also do similar for this MOI, setup. This is the account that is required for deployment of a smart contract. So if you're going to be running this, if you're going to be deploying to MOI network, you need to make sure that you have this private key, as part of private key to be part of your hard deployment. Okay, you can select private key from your MetaMask and add it here. Okay, for an account that has an Ether, it's some Polygon Matic, on the testnet that will allow this. And then this is the type chain directory. This is output directory, and this is the target version of Ethers.js compatibility, which is version 6. And this is the type chain. That is why we have this folder here, type chain. Okay, so this is the output directory. And then the path for the smart contract is contract. That's why we have this test directory is test. Cache directory is this cache, and the artifact directory is this artifact. Okay, I think you can also put script directory if you want to. So now that you have all those things, that's why we have these networks. These networks enable us to access those information. Great. So I'm going to get this deployer, the signer, right? So because we're working with Haddad, the signer, is defaulted to those dummy ones that the network provide. But if you're deploying to a chain such as Amoi, it's going to default to these ones you specified here. All right, so that's what we have. This deployer, which is going to be the very first account. Remember how it is strategically put inside an array. Okay, so the very first account is going to be retrieved through this get signer. All right, so once we get the signer, we want to also log the network. All right, and the deployer address is the person that is going to be deploying the smart contract. This is the network that the smart contract is going to be deployed on, right? And we want to see the account balance. We want to actually log the account balance of the person that is of this deployer currently. So you can do that. You just add that environment.ethers provider.get balance, get the deployer's account balance. All right, so initially it's going to be something really large. Okay, more like 1 ether or 1,000 or 10,000 ethers. Now, after this is successful, you want to deploy the Rumble Court contract, because all this while we've been doing setup, we've not done any deployment yet. So we're just setting up an environment and the necessary deployment steps. So you want to get the contract factory. Okay, this step is very important. Contract factory for Rumble Court. All right, and then you want to deploy that smart contract. You deploy this contract using this Rumble Court factory deploy, and you await for a completion, and you then call this await here, Rumble Court await. Wait for deployment to complete. And once deployment is complete, we can then have access to the contract address. Okay, this is the contract address, and we get the deployment transaction, the Rumble Code deployment transaction. right? So that is give you the transaction hash record, and you want to just log out those information on the terminal. All right, so say Rumble code deployed successfully. Contract address is this, and transaction hash is this. Okay, so that is what it is. And you just log an empty string so that you can break stuff down. Now it is time for us to save the deployment record, because this is one of the problem we had that I wouldn't have to do this next step if whatever that is being built in the artifact, for example, this contract record, contain the smart contract address here. If it did contain the smart contract address by default, then I won't have to do this next step. Okay, it is because it doesn't contain that smart contract address I have to do this next step. Okay, this build information, they don't contain the smart contract address. All right, which this is this is the annoying stuff about Solidity smart contracts and the deployment procedures. So I have to do this, my own, right? That is why we're having this whole step, and that is why this deployment script is even lengthier. So the first thing I want to do is the deployment directory, which is I pass this part to this deployment part. So this part.die, this is where I want to dump these deployment records that I'm about to create. The first thing I want to do is I want to check this directory, create the directory. This creates the directory if it does not exist. You understand that? So it creates it, and if there are other sub directories in it, it also creates it. So it create this and create this file and have it all ready for us by default. Right? So we'll first of all we're checking first. This checks, and then the next step is to make that directory. All right, that's why we have this step here. We make this directory by saying make directory strings of this. Is checking if it does not exist, then it should just make the directory. And recursive means that every other directory that are part of this path, okay, then it should all be created if it doesn't exist. So this will make sure that location where we want to dump our deployment information is always available. I want to create a deployment variable that will be a type of this deployment file here. This deployment info or deployment file here, it will take on that structure, and by default is an empty object. Now we want to see if, similar to what we did here, so I want to say if this particular path exists. So it checks if the path exists. Then we want to see deployment. We're calling on this. It's going to be called to JSON.pass. And what are we passing? First of all, we're passing that file. All right. Passing fs.read pricing, this deployment path. Okay, in UTF. All right, and then that is the record that we want to come back here. Okay, so you want to do it as deployment info. So now it's time for us to use it. So basically what this does is to make sure that if there were a deployment record that existed before, then you should read it as part of the new record, but we're gonna also be able to update it. Okay, so in case, for example, if we have multiple deployments and it is there, we will not have to lose those records. I mean, if we have multiple deployments that are facing different networks, say for another one, for example, one is facing, a production network or a test network. Another one is facing a local network. We won't have to lose all those deployments, so we'll be able to capture all the deployments along. That is the purpose of this line of code. All right. So since we got that, we then need to make sure that we have the right deployment key. Environment, is it local? If so, we want local. Otherwise, we want production. So this environment here is already defined as local by default. So now that we have the deployment key, because we want to deploy either local or production, we want two categories of deployment to be available. All right. So do you see the way we define this here? This is how we now going to be structuring. I'm going to copy this closer so that we can model it. All right. So that's what we're going to be doing on this. I want to say deployment now is equal to deployment, and then we target that deployment key, just like with this. You can see these steps here. The deployment key, and I'm going to say is equal to this object. Now we can remove this because we don't need it anymore. All right. Sorry, I made a mistake here. This is as deployment file, not deployment info. All right. So here we will see this network will define, that a deployment file contains the network, and this is now the deployment info. Right, so the deployment info, that's what we're trying to model. Okay, all this information, we're going to supply them, and let's apply them. I'm just going to paste it, so we don't have to spend time. All right, so the network is going to be this network we created earlier in one of these, and then the deploy that will be current time. Deployer address is going to be this. Contract address is going to be this contract address here. Okay, and then transaction hash, you're targeting. If it does that, if it has that, you just give it all is unknown by default. Great. So now that we define the record that we would like to save in that file, in the deployment script or deployment file, then we'll need to then dump it, save it, or override the existing one. We'll say fs.write file sync the deployment part, and then you do json.stringify the deployment record, which is this, and which will contain whatever number of deployment that you have based on either local or production, and then give the indentation to be what to be replacer to be null. Replacer could be like some kind of an inline function also, and then indentation, or space to be 2. So by default, so this will write to that location. So that is good. And then we want to see deployment information has been stored correctly. Right. Fantastic. So you want to dump some final records into the browser. Okay. So I'm gonna drop these final logs. Right. So we say deployment summary, the network that was deployed, the contract address, the owner. You understand that? So that will be enough for the most important aspect. So this main function has not been used yet, so it's still not executable. We need to execute it, and you do to execute it, do main, and then you should then, okay, the process dot exit with error, or if there's an issue, capture that error and do the following. Just drop here's a deployment field and to drop the error and all that. So this is what the deployment script entails. So now let's try and deploy without, let's say we don't have what's it called, I need to streamline some things. Let me open this file, package.json. Come here. This is a deployment script. Okay, this is how we use in deploying the command we use in deploying on localhost and on production. All right, so for localhost, I just do yarn or npx. All right, say hard and say run scripts slash deploy. Yes, you select network that you want to deploy it to, and we're going to be using localhost. Now, this localhost was specified here, so this is the network that we're accessing. So you make sure that any network you call in is actually there, right? So you run this. It should fail because hard is not running. You can say, please make sure your node is running, check your internet connection and so on. So that's what I want to do. Yarn or npx hard node, right? And you can see the private keys. These are just dummy accounts loaded with 10,000 ethers each for testing purposes only. You can see the URL that it matches with all this that we had already specified. Fantastic. So at this point, we're going to run that command again. Not this one. No, not this one either. I'm going to just copy this line. So I don't type the entire thing. When you run it on a terminal, you can't just run it this. Okay, you need to append that npx or yarn in front of it. I say yarn, you run this. See how it's deployed the smart contract on the web on that platform, and see some readings. Okay, that it has received a transaction called Rumble, and this is the contract details here. Okay, this is the record that was used. You can see the gas that was used, value, and all of those things, transaction, record, hash, and all that. So what about the deployment folder? Did it create it? Let's check. Yeah, you can see this deployment folder now. You can see that it has localhost. This is for local network. See localhost, you can see the time that it deployed the deployer corresponding with this what's it called, with this from directory. The contract address is corresponding with this, and the transaction hash is corresponding with this standard. So this verifies that our smart contract is officially being deployed on the network. Now this file is going to be important in the next stage now that we're going to be jumping into, and this next stage is about what's it called, blockchain integration. So we're going to be creating like an interface, also a file service that we can consume across our application, and also make it available for our MCP server to operate later on. So that file is very important, which I'm going to show you in the next part of this video. Okay, so it is time for us to create a blockchain service. Is a very important script a service, sorry, services slash blockchain dot TypeScript. So this is gonna be what we will be communicating throughout our front end. So our front end will be interacting with this file, and this file interacts with the smart contract and does all the whole blockchain business for us. The first thing I want to do is bring in Ethereum.js, because that is what you use in um, that is what you use in communicating with the smart contract. And of course, we want to import rumble quotes, okay, from that artifact. Remember, we built this artifact, the contract, and you want to import this file here. You want to say from da 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 da. Hold on, come out there and go to artifacts. Okay, contract. Sorry, not build information. Contract slash yeah. Okay, and then slash JSON. Boom. As you can see, slash this folder that has a Solidity extension, and then this JSON file. So you want to grab that, very important. And you want to grab the deployment. That is this particular script now that is coming here. Want to grab it as well. We'll call this one the deployment contract. So we say import deployment address. Okay, and we're going to grab it from deployment slash rumble quote. So we got all this. Great. Now we're going to use it later on, or let's just continue. The first thing I want to do, I want to define some important case status. All right, so the case status I want to define is pending, in trial, completed, and appeal. Okay, just in line with the case status in the smart contract. I also want to get the verdict type as well, which include guilty, not guilty, settlement, and dismiss. And afterward, I want to define the interface of a case. So a case has case ID, plaintiff, same thing as it is with the smart contract. Okay? So, and then I also want to define the verdict structure as well. Call it interface here, but in Solidity you call it struct. All right, so this is it as well. Very similar to what we did in the smart contract. And now you want to manage the contract address. Okay, so contract address management. This is how we will work with this first. We want to create a new function, and this function is going to be called get contract address. And in getting contract address, the first thing I want to do is to determine the environment that I'm working on. All right, so the environment matters. Default is local. All right, so after I determine the environment, I will then do this. Deployment key will be based on either local, if it is local, or production, if it is production. All right, and once I get that, I want to grab the deployment now, the deployment record. Okay, and how you get it is by saying const the deployment is equal to you call out deployment address, and then you're passing in this key. Okay, when you pass in that key, you want to typecast this to say that it's as of a key of the keys of deployment, address. Okay, so you do that. And then once you do that, you can then grab the address. Okay, address is equal to this deployment now, and then call on the contract address. At this point, you have the address, but we still have more things to be done here. It's supposed to return a string at the end of the day, so it hasn't done that yet. You need to test that that address is present. So you say if the address is not present, so there is no address, then you should just log contract address not found for environments. Okay, and you also throw this error as well. Okay, and once you do that, you return the address, and that fulfills the criteria for this function. And then we can use this contract address later on when we start interacting. So quickly, you want to jump in here and say this get contract address, that you now have the contract address in this variable here of constant. So the next thing you want to do is to do work on provider management. Okay, once you grab the address, you want to do provider management now. And in provider management, we need a new function called get contract read only. Now I'm going to tell you there are two kinds of basically the same two kinds of functions that will serve the purpose of retrieving the contract instance. One is going to be for read-only operations, while the other is going to be for read-write operations. The read-write operations are going to be specifically for calling functions that require signature from MetaMask. So if they don't require signatures from MetaMask and it's just a read operation, then this is where this particular function comes into play. And the first thing I want to do, like I'm going to open this example, one of the things is to get a public URL, RPC URL. So that is in the main environment variable, but I'm not going to open it. So you come here, say grab that RPC URL, and once you do so, you check if it actually exists. All right, so if it actually exists, remember this is what we expect to return at the end of the day, so we haven't yet fulfilled that. Okay, so you want to get the provider now. The provider is going to be, you say provider is equal to a new ethers.js.json RPC, then you pass in the URL of that RPC, right? And once you do that, you return new ethers.contract, pass the contract address, the Rumble, called ABI, and then the provider. So you pass in those things, and at this point you have your read-only function available. Now we also need a read-write function. Okay, a read-write function, and this is going to be promise based. Okay, that means it's an asynchronous type, unlike this one, which isn't. So this is asynchronous based, is an async function, and it's expected to return contract but wrapped in this promise. So we're going to be awaiting for it. That's what it simply means. So you want to make sure that before you call this function, the browser window is fully loaded. That's why we put in this line. The type of window is also undefined. Then you should throw that. Otherwise, you should move forward. All right. And so when we've determined that we are in the Windows, we are in the browser environment, the next thing we want to do is to check if the browser has an Ethereum wallet, which, for example, with MetaMask in this case. So that is the second check that we're going to do. So if it is not a, if there is no Ethereum object in it, it's a no browser wallet available, please connect your wallet. Very important. Now we're going to be using this try catch. Okay. This try catch is important for a safer way of managing a condition where something fails, an error, um, inevitably shows up. So otherwise, you see the way we got this provider here. For this provider is JSON RPC based provider. But if you're dealing with MetaMask wallet, this is how you get it. It's a new Next.js browser provider is different from JSON RPC provider. And you're passing the Windows.Ethereum object, which is the MetaMask or whatever that you're using, that will be responsible for authenticating signers and signing transactions. Now, once you do that, you want to call on, you want to get the signer or the person that is, or the one that is currently logged in into sign into that particular browser. You want the currently connected wallet address. Okay, so you say await. You see why we're using await here. You sync await, then get it, and the signer is stored here. And at the end of the day, you just want to return a new contract similar to basically the same thing that we did before. And if there is any error, I want to say if there is any error, we want to just log out those errors here. Okay, so this is what we're doing. Very straightforward. So with this, you get the ABI, have the signer, you have the contract address, everything is all set. So this is get contract with signer. Fantastic. These functions are foundational. The rest of the interactions of the with the various functions in the smart contract are going to be heavily dependent on what we have done here so far. So now I want to say error handling. The error handling help. I want to define one. Let's create a function that will handle errors for us. Okay, call it report error. And you want to make sure that different types of error have, different types of error have various way of reporting them. So I'm going to put this here. Okay, this has to be outside here. Okay, better. So now this report error is going to check the instance of that error. If it's an error object, then you should just log out the error message or the error stack. And if the type is an object, it just stringifies it first and logs it out. No, so just a handy error reporting function. So these are write operations. Write operations are operations that are going to require, MetaMask, confirmation. So we need to confirm it with MetaMask before proceeding. So that is what a write operation is about. So for example, the first one we'll do is about filing a case. You need the title and an evidence hash, which is basically a string in this case. And we're expecting to return a transaction, response. Okay, as what validates that what we're doing succeeded. So of course, you want to make sure that you have this try catch thing on a lockdown. If there is any error, you want to just expose it right there. So now let's jump into the main thing. For us, first step we want to do, we want to grab the contract. All right. Once we grab the contract, then we can do this step, which I don't think is quite necessary. But this step is basically to check if we have a function called in this contract the dot five keys. Okay. If there's no function, we want to say contract missing 5 case method check ABI. So this is just some protective mechanisms. All right. So it is very important that the contract has that function. Otherwise, we can then call that function here. All right. So we say contract await dot 5 case, and then we pass in the case title and ID, and then you return this. Or before we return this, need some procedure. Want to check if this transaction has a wait method in it, because we're expecting it to wait before, so that the transaction can be confirmed before it proceeds, right? And if it does have that method in it, we can log it up. Okay, and log it off, and we just do, this is where we actually do the waiting, right? So we say await tx.wait. This we wait for the transaction to be completed, and once the transaction is complete, then we can just log it out in the console and see that the file transaction confirmed, 5 case transaction has been confirmed. So that helps you to create file in a new case. Okay, now I'm gonna be a little bit faster. I'm basically just gonna paste in some of these to make it faster, because you already know how it goes. So this is the second function called export start trial. Of course, we're going to need a case ID, and we're using begins. Okay, and grab the contract, of course, and we're just saying that we started the trial, and we pass in the case ID as string, and we start the case, because you need to send this case ID as a big int, not just as a regular integer. All right. So this is the moment where the wallet pops up. Okay, and then we ensure that wait function is part of it. The wait is successful, and then you return the transaction hash. That's why we have this. It has those transaction response, right? So that is how you start trial. It's basically interacting with those functions. You also need to start that is called another function called record verdict. You need case ID, you need verdict type, which is number, as numbers in enum, like 1 2 1 2 3 4, but it actually starts with 0 2 3, not 1 2 4. And then the reasoning string and its final. These are the various record that we need to pass into the blockchain. Now you get contract, the one with signer, and you log off this information on the console. Okay, and then you make that call, to record that verdict on the blockchain. This is basically where the MetaMask pops up. Okay, and once that is successful, it returns the result. Basically the same approach, the same approach. That's one of the things I enjoy about this. You don't need to change too many things, just the same approach. For appeal, you need to pass the case ID, get the contract, you call that function on the smart contract by passing the ID, case ID, and then you wait for it to be confirmed, you return the case ID. I mean the transaction reference or receipt. So that is what you need. So we're done with all those read write operation or write operations. Now we want to do read operations. And read operations are necessary for grabbing record on a blockchain. Okay, so this is a write operation and it's called get case. You pass in the case ID, it gets the contract that is read only. You call the smart contract with that ID and then you return that case ID but formatted. Now I want to show you how we format data. So I'm going to create a helper. So data formatting helper. So format case. All right. We format the case because we need we first want to do, we want to log out the raw data. All right. And you want to define an interface called raw case. All right. We have raw case here, raw case data, and these are the case. A case ID can either be a big int, number, or a string, and all of those things. These are the raw format of it. And you want to define the data as what raw case. Okay. After you've done this, you want to see check is if array dot is arrays is actually case data. What we're going to do here is the data we're going to assign is enter it. So this data here, I'm going to see is an object. We pass in the first item in that data as any one of these. Just the same way we defined all this, we just make sure that they are the same type. All right. Else, you want this data to be a definition of the raw data. Okay. And after this if statement is done, we want to say status number. So status, which is a number, and then we want to say raw status, which is data dot status. This data here, there is a status property in it. Want to access that, and want to do some checks. The checks we're going to be doing is we want to say if type of raw status is a big int, then we want to convert it to a number, and then we'll say this status now is actually a number. All right, that is very important for us. Else if that is not the case, that means if it's not the case and this case is the type of raw status is actually a string, then I want to check if it's not none, right, by converting it to number and then checking if it's not none. That means if it's not an empty number or an empty string, and then assign, also do the same thing by assigning the status to the number. Okay, but if the string contains status number like completed, then you just want to define this record is basically like an enum, and then you pass in whatever that status is in uppercase, so basically mimicking this order, and then or the default is 0, and then that will become what it is here in the status number. And lastly, an else statement. Okay, else. All right, you just want to, it's already a number, so we just put it there as number. So these are protective mechanisms to ensure that what we are doing is accurate. So we're going to write, want to convert the status number to enum string. All right, so we're saying that formatted status is going to be format status, and then we pass in this status number. Now we don't yet have this function here. We need to create it down below. So it's not going to be very lengthy, so I'm just going to paste it below here. The formatted status is actually passing a number, and it's supposed to return a case status. All right, case status can either be pending, in trial, completed, appeal. So these are the various case status. Okay, and want to check validate it status is in the range. So the status shouldn't be less than 0, and it shouldn't be more than the length of this array, which is basically 4. So if it is less than 0 or is greater than the status range, okay, then you say invalid status value, and returns ending. Right, very, very important. Now that we have that working out, let's go back to completing this. So we want to return the properties, case ID, it should be in big int, native string, and we just convert them to their proper, corresponding status. So that particular this particular example, okay, a lot. All right, so now that we have that structured, let's go back to finishing the rest of those read only operations. So we have another function. This one is a little bit large. This function is called get user cases, and it's supposed to return a promise of big int array, which is just all the cases of the user. And you want to make sure that you have try catch on a lockdown here. I'm going to just report the error in case there is one. So let's work on this place. In working on this, first thing I want to do is to get the contract read-only, non-negotiable. Once you get the contract read-only, you want to grab the case ID from the contract. Okay, so the case IDs is going to be called await contract.get users cases, and then you pass in that user, which is a string, which is an address, and then it's returning an array, but we want that array to be converted, if it's not already, to a big int, or to be regarded as a big integer array. All right, and that's good. Now I want to fetch the full case data for each ID, so we can sort them using promise.all. All right, so in JavaScript, there's this thing called promise.all, where you can just set up something and trigger it one time in a synchronous request. Okay, so promise.all, I want to pass in this case ID, which is an array mapped through each one of those case IDs, and then all right, let's do this case ID. Okay, for every case ID, I want to do case data. I want to say await get case ID, and then you want to return not the case data alone, you want to return that it's case ID. Okay, so this is what you're returning, the case ID and the case data together at once. So this is it now, and of course this needs to be executed. So it's declared but never read, so it's not being executed yet. The next thing I want to do is to sort the cases. All right, so this is like a sort function. So in this sort function, we're first of all going to be defining the status properties. Okay, going to be status properties include completed, in trial, pending, and approval, just as you've known before. And then the priority, that priority A, status property, priority B. Okay, so then we'll sort it by saying if priority, sorry, so if they have the same status, it should be sorted by the most recent. All right, so if priority A and priority B are actually the same, then it should be sorted by the file created at, so the one that was most recently created will be at the top. That is what we are doing. And then at the end of the day, you want to return that. We also want to return this this sorted classes, a cases. So you map through them and you return. Just go by C as for case, and then you return the case in a sorted order. Look at it now again. Right here, we define a promise.all that will grab us all the cases that belongs to a specific user, and then we sorted it all out. After we sorted them in according to priority completed by showing completed first, and then in trial second, pending third, and then appeal last. So what if the priorities among the cases are the same, then the second criteria count, which is to sort it by the time. All right, the time that the most recently created one. So that is what is happening there. This is why the function is a little bit lengthy. Other than that, it was all good. All right, and want to get another function. This is called get total cases. All right, very short one. You just grab the contract and return the total number of cases as big int. So that's what it does. All right, promise based you, and want to get verdict for a specific case. The verdict for a specific case is it's going to be based on this verdict here that is above. Remember, we had that verdict above there, and you grab the contract, you grab the verdict, passing the case ID, and then you return the verdict data, or you need to format it. We don't yet have that function, so we need to create it ourselves. Okay, so called format verdict. Let's work on it. So I'm gonna put it just below here. So this is the function. So we need to define the expected structure of the raw verdict. All right. Once we do that, we want to say, want to define v, which is, the valid data, this one here, saying v is equal to this valid data, but we're assigning it as the raw valid data. Okay, and we just want to return it by formatting it. So we say return by formatting each one of those records, which we include case ID, the valid type, the reasoning, timestamp, and its final. This we also need to format it as well. So let's have a function here. Okay, so we have a function called format. Sorry, not that one. Sorry. I have a function here called format valid type. Okay, so you pass in the type number, and then these are all the verdicts. Duties 0, and then these are all just their order. And then based on the number of the verdict that's been passed, is going to return that type. Otherwise, just going to return dismissed for us. Right. So that is the main purpose of these purpose of this function here. So that is clear. And we have some other functions that we need to work on. Now that is for, I think we have 2 more functions on the read-only. Look at this function called as verdict. You pass in a case ID, and it just grabs you that verdict status, which is going to be a boolean, so returns true or false, right? And we have another one, which is to get the owner of this smart contract, the owner, by calling on that owner property, and it will return a string for us. And lastly, you want to return the contract address. This could be very handy as well. So, get contract address export. You return the contract address like that. So these are the most important ones, but there is one more set of functions that we need to work on. All right, so this is called event listeners. Event listener, these are real-time operations. Okay, and it's very interesting because even if your smart contract, let's say for example, with this sort of event, they could be listening to the smart contract, and let's say this contract is also being utilized by another application somewhere else, and a transaction happens, such as a case was filed, and these events are listening. They are going to update your application at real time because they are listening. That is how cool these ones they are. I've never brought this in, but this is the first time I'm doing that. So, so this is called on case file. On case, so whenever a case is filed, all right, these particular one fires. All right, what we need is it passes in, it takes in a callback function. It takes in one callback function, and that callback function is going to have to accept a case ID, a plaintiff, a case title. Basically, this is what is coming as from what is coming from an event, on case when events are emitted for case submission. Okay, so then you want to do a try catch, of course. Always do a try catch when you're dealing with the blockchain. Okay, so let's do this now. Here you want to get the contract first. The contract you're getting is the read-only contract, because that's all we are doing here. So, and then we want to register an event listener, and I'm going to take my time to do this part because I've not done it before on this channel. So let's do it. Contract dot on. Okay, on is specifically write the name of that event. On case file, this is what we want to do. We want to pass in the following. I'm gonna come back to this. The case ID, we're just gonna pass in unknown here, unknown here, and unknown here. Okay, because you don't want to definitely give it. You're gonna convert unknown type to their proper types, and call back. So once we do this, you want to then do that callback function. Remember that we pass in here. You want to then say that the case ID is going to be, a big int, a number, or a string. So you're properly converting it. And these ones, you want to convert them to what are strings. So that is how you listen for case filing. All right, so let's create the rest of the functions, for trials, and for the one starting to start the trial is basically similar. Okay, so when we're starting a trial, do callback, we passing that callback, but this time only with because this callback is going to be a function that we will connect to this, we're going to be connecting it to this place so that we can carry out some operations later on the front end. So we're doing this, we're just setting it up this way. Okay, of course, you know the drill. You grab the contract read only, and the event that you're looking for is this trial started, and this is the case ID, it's unknown. Then you now convert it back, to a string, to either one of these. All right, so also for verdict recording, in case there's a verdict that was passed. All right, so you also want to write another event listener for it. So a verdict need case ID, verdict type, and spinner. And then you grab the read-only, contract read-only. What you're looking for, remember, is verdict recorded, and you want to pass in the case ID, the verdict type, unknown, and is final. Then you also make sure you convert it properly to their appropriate type as you're passing it back into that callback function, and that is it. So, and I guess one more list monitoring function will be on case appeal. So whenever there's a case that has been appealed, it's the same thing, which this is the event listen to, and then you make sure that you pass that information back to the callback function, and that is it. As as basically all the functions that we need to have on board in order to properly operate this system. Probably I'm missing something. Let me check. Okay, so I don't think I'm missing any major function. So, and if there is anything missing, we can always jump back and fix it. So in the next part of this video, I'm going to be showing you how you connect this blockchain service now as it is to an MCP server that we're going to be creating, because this project requires that we have an MCP server. That MCP server is going to expose all these various functions as tools to the LLM agent that we're going to be using, so that when we're communicating on the front end, the LLM agent can call any one of those tools when they are required. All right, so I'll see you in the next part of this video. All right, so before we move forward and start integrating MCP and plus LLM integrations, all those things, I would like to test out the blockchain service that we just finished creating. So I'm going to spin off this project so we can look at it. Okay, so this documentation page is very important that it was working. Okay, but currently it doesn't work, as you can see. All this, okay, there is nothing like I try to get case. It's just a dummy space. Okay, so we want to start interacting with this particular page, right? So that it is currently everything is is very dummy. Everything is a dummy. Right, so let's integrate that blockchain service that we've been working on in here so that we can test out the button functions ourselves to verify that everything is working. To do that, you come here, you open that page, which is the document page, /docs. I'm going to open the docs page. Okay, the docs is in page, now you open it. So it's a long list of items. Okay, so and in this long list of items, we are using the types that are here already. So these are some types that defines what a case is, what a verdict is, and all of that. So with that stated, we're going to need a case, a verdict, and a verdict type. So these are the things that it will include. So the first thing I want to do is I want to import the blockchain service, functions. Right. So these are the various functions that I'm going to be using in this blockchain service. So after pasting this, we're going to need to remove this order, or we just comment it out for now. Okay. So this will be real blockchain, service files. Very important. Right. So we're going to target some things. We're going to look for anywhere we find dummy. Let's look for it and see this dummy dot get owner. We can just move this, look for wherever we find each one, and we don't need to append or prepend any dummy to it, so we need to replace it with empty. So remember, I'm searching for dummy and then with that dot in front of it, and I'm replacing it with empty space. So it's going to replace all with that, and all of them are replaced at once. And see, all of a sudden we don't have need for this entire function. So I'm going to just remove it. Okay. All right, we can remove this as well. Okay. We see, but there are still some things to be done. We have places here where let's look for where we have things like dummy case, and then we're having all this dot title, dot evidence, and all that. We're gonna have to remove that. I think it's found this, so let's remove those. We can replace it the same way. It is gone. Actually, we didn't need to remove those dummy stuff here. Okay, so all we need to do is I'm going to update this to be much cleaner and shorter. Okay, these are some dummy cases, and this is only necessary for this function of generating dummy cases. Okay, so that is what happens there, and we're going to remove this because filing of cases does not require that. All right. Okay, so and we can customize this message thing that generated, number of cases and all that. So that is what you do. You can save that. All right. Here too, you want to remove this. It doesn't take, that extra parameter. We are still coming. So we want to update the message URL. Okay, we're gonna look for where we have this. We're gonna update this message a little bit. Okay, so instead of saying wallet connected successfully and all these other extra jargons, we need to remove that. So we need to also remove everything that reference demo simulation, which you can find here. For example, this is demo mode. When talking about sandbox. Okay, so that demo mode, we need to update it. So we're gonna say instead the test minimal blockchain courtroom, right? And also want to update this verdict place that was giving us an issue. Okay, come here and set that verdict. This is the very place that's producing an error. So we need to update that. This is what we'll update it to. Just the verdict type, straightforward, no hiccups. All right, and as we do that, I already see that the page is already cool. Everything seems to be aligned. All right, so let's look at it. Let's try and file in a case. Social media regulation for children slash young adult under 17. Do you agree or not? So I'm just saying Lawrence, and we're just going to bring this instead. Okay, so let's click on file case. Oh, we can see that is working. We just click on confirm now, and it is that it actually succeeded. Right, so that means the case ID should be 1. Now let's get the case. You can see that that case is actually in the blockchain, and then this is the user. Of course, if I paste this here and get case, you can see that this has only 1 case. So that seems to be working just fine. So which are the most important buttons? If I say start trial, we can be able to start trial. You can see that, and click confirm, trial started. If I come to this case here and get this case again, you can see it's 9 on trial, which is interesting. And for the case ID, if I give it the, let's say guilty, okay, and we can write whatever thing, give is final, and see what can we say. let's leave it alone. Okay, we can click on get verdict or check status. Let's say get verdict. Okay, so there's no verdict on that. Check status, no verdict found for this. So the AI will be it. The AI will easily be able to translate this, but so we can be very sure that that is working out for us. And this is a great advantage because from now henceforth, we can be confident that when we jump into um, the MCP part and also for the LLM integration, it will follow a tested, system. So I'm going to see in the next part of this video. Hope this was not very freaky. It's just to edit those little spaces that I, indicated. That is all. There's nothing crazy about it. So because we didn't want to write all the front end ourselves, that's why I did it ahead of time to make sure that all you need to do is integration. The integration part is the most important part. The back end creation and in the integration part, that is the part that you need to focus on if you already have your front end solid, because that's what you need to do. So I'm going to see in the next part of this video. Okay, so to begin creating the MCP tools, we'll be doing that in this library, in this folder here. We're going to call it Courtroom MCP -tools.ts TypeScript. So within this tool, we're going to be making use of some essential stuff. I'm going to open this. So we're going to be making use of AI library and Zod library. For some reason I'm not seeing that Zod here listed. So listed, but it's an essential part. Maybe it's within another package, So let's come back here. So going to be importing tools from AI, and this AI SDK is used to define MCP tools. Okay, so MCP tools in a nutshell allows AI agent to interact with external system. Okay, so this blockchain service is completely external to the LLM agent. So for the LLM agent to talk with the blockchain, it needs an MCP set of tools. So that's how we're using that. We're using this AI. And also we have Zod. Zod is very important to validate schemas. Zod ensures that we ensure that the two inputs have the correct types and formats. Very important to make sure that things stay in the right, order. So we're going to also bring in some important tools that we're going to be given to functions that we want to provide the LLM. Okay, so the functions I want to provide the LLM include, the file URL, the filing of cases, and all of these ones here. Okay, so these are the major functions that we want to give the LLM. So those are the imports that we're going to be needing, and then we want a wallet context. All right, so for wallet context, we want to define a wallet, to have the following status. Is connected is Boolean, address is either string or null, is owner is Boolean, and I'm going to give it these default values. So we have a function here, and I would just like to explain some of these things before we move forward, that to help our understanding. So it's connected, tells us whether wallet is connected or not. So that's why I have this address, tells us whether the user's Ethereum. It just gives us information about the user's Ethereum's address, and its owner tells us um, whether the user is a contract owner or not. That means the deployer. Okay, so we want to create a function below here. This function will help us to set wallet context for the MCP, because this is just a definition right now, but it has not been set. So we need a function that will help us to do that. So let's define a function. Okay, function, and it's going to return void, and we want it to set the wallet context for us. Okay, and of course we want this to be exportable. Okay, so that is what this function is going to be doing when it is invoked. All right now it's not been invoked, so but that is what you should know concerning wallet context. They are a very essential set of tools that we need to have there. Now we need another set of tools called authorization helpers. So for authorization helpers, we need one called require wallet. Okay, so in this require wallet, we want to check if wallet is not already connected. Okay, or the wallet address is missing. Okay, then you should just return a simple message. All right, so it's going to return a simple message saying wallet is not connected, please, or user address is not available. So either one of these actions will be the response. And if there are no errors, it will just return an empty object. Okay, so we'll move on to the next helper. This next helper is going to be about that it requires the owner, and for this we need to first require wallet. We need to check that wallet is active. So if there is any issue with the wallet check, if there is an error, then it should return the wallet check. Okay, we can just do it in one line code like this. All right, so like that. So if this has no issue, then we move on to this next step. We want to check, is this wallet context the owner? Dot owner, if there is an owner. Okay, if there are no owner, we want to say that this operation requires the system owner. Okay, so this operation requires system owner privilege. Only the contract owner can perform this action. All right, so this is require owner, very important. Now that we define that function, we need a response formatting helpers. Okay, so these are just preliminary tools. And now for each one of these helpers, you want to annotate these things very well. You're not dealing with a regular functions anymore. You want to make sure that whatever you put in here is well annotated. So that is the purpose of MCP tools. All right, so I'm going to annotate these other ones that I skipped, like for example require the require wallet. Okay, we need to make sure that we annotate that, give a proper description. So returns empty object, if okay, or object with error. All right. So we need to also annotate this correctly. So empty object if okay, or with error. So those two, they do that. And for this next step, we want to annotate this function very well as well. This response formatting. This helps us to format transaction response and create a standardized success response for blockchain interaction. So this is TX, transaction object, message, success, and additional data. So let's create that function. We have this function like this. This function, because you see how meticulous it is. Each one of the input or arguments are passed down there and well specified for ease of understanding. All right, so this will really help the LLM to quickly understand what is going on here. All right, so this is the format that we're expecting success through. Is that you format a transaction response, message transaction hash, the block number where the transaction is included, because transactions are included in blocks. So a block has multiple transactions, and then additional data that are spread for any, so that is it. And we also want another function from annotation. So this time around, we want to create this function below. We have error context and just a return statement. We'll call it format error. That's what this function does. So it takes in an error, the context, which is a string, and then it will check error message, check if error is an instance of error object, or if so, then you should return the message because that be present there. Otherwise, you just convert the entire record into a string, and then we can output it. Success is false, error, you pass in the context, and then the error message. So these are very important. So now we have all those things. We need to define the main things, which are the MCP tool definition. Very important. So how do you define MCP tool? You put them in one umbrella function or umbrella object, sorry. So this umbrella object is going to be called MCP Tools, and you want to make it exportable. And so within that, we want to first work on the wallet tools. Okay. Because there are various tools, I'm going to work on the wallet tools first. So what is it about this wallet tool? This is how you define a tool. A tool is all based on the way you define a function. Okay, but in an key value type, in a key value set. So for example, this is the key get connected wallet, and then you just pass in, then you use the tool from what is it called, AI. Remember that tool here. You now make use of it. Okay, so a tool has the following information. It has a description, okay, and you need to make sure that you properly describe what this tool is expected to do. Very important. This is non-negotiable, right? So you have description. These two get information about currently connected wallet and its connected status, period. All right. And then you want to define an empty Zod schema. I'm going to work on it. An empty Zod schema object. Okay. Now you want, so this would be where all the parameters, you know, uh, that the tools we accept, this is where it's going to be, this is what we defines it. Okay. And in this case is empty because we don't need to pass any, parameters. All right. That's why it's empty. And now we need another function, within it now we need another function which is called executable. So we say execute, and execute is going to be an asynchronous function. All right. This asynchronous function, what we want to do, we want to first check if the wallet is connected, because if the wallet is connected, okay, if it's not connected, or there is not wallet address, then you should return a message. Okay, the message should be, should contain some record. Let me put that here. So these are the message. Connected status be false. The message is no wallet connected. Please connect your wallet to use Rumble-Cut, period. So, but if this passed successfully, then the next phase, which is to return the wallet information. So here are the wallet information. Okay. Well, we need to return connected status to be true, the user's address, the owner's, the status, whether it's an owner or not, and then the wallet, if it is connected, if the message is wallet is connected and ready. And then you have this wallet address which you grab from the blockchain function. So this is the first function that we are using here. Return the blockchain, the currently connected wallet address. The contract address, sorry, not the wallet, the user wallet address, the contract address. So this is the first two, and we've dealt with that. So this is the pretext for defining other tools. You're going to use this pattern that we have established now. Great. So let's go and move on to the next set of tools. The next set of tools we want to do is the write operation tools. So the tools that will help us to do write operations to the blockchain. So there is some form of a similarity between how we define all these tools and now, but this is how the AI consumes it. This is how we can integrate it on a front end with our own buttons and all the clickable things. But this is how an AI can interact, or an LLM can interact with these tools without needing buttons and all of that. So just by tool calling. Now I'm having um, another situation here. This is going to be called want to file a case. So in filing a case, we need another tool. I'm going to call this tool. We're going to call this tool file case, and the description is file a new case on the blockchain, require wallet connection, provide the case title and evidence, which is hash slash description. You see how clean the description is. That is how you need to make sure that it is. So now we need to define the various things that we expect, that the various parameters that are expected from the LLM agent to pass into this tool when it is calling it. First thing you want to do is the case title. Okay, the case title must be a string. Okay, it must be a string, and you want to give it a description, describe it briefly. So I'm going to come here and give it a better description. So you require it to be a string, right? And the evidence hash, the evidence. So the evidence hash is also a string, and you describe it as IPFS hash or description. Okay, so describe it this way: IPFS hash or description of evidence, right? So those are the two important, parameters that we're passing into this um into this tool whenever it's going to be called. These are the things that is going to be required, and this is very good. Now, once you give a definition of the tool, give the parameter definition, and then you now give the next one, which is the execute function. Okay, in this execute function, now you pass in the two parameters that we're going to be using, and of course you want to make sure that it checks wallet, just as which one, just like, okay, yeah. So what you want to do, you want to check the wallet status, and if the wallet doesn't return any error, then we'll proceed here. Okay, want to do try catch. Great. And if there is any error, we want to format that error and return it. So you return format error, passing the error as a failed to file case. Otherwise, this is where we'll spend our time now. First thing you want to do is the transaction. You want to call on await file case. You pass in the parameters, and if that was successful, then we want to return format transaction response. So you pass in the transaction, this passing the transaction, then you pass in the what's it called, a message or a success message. So we're going to interpolate it with the case title. But additionally, these are the additional record. Want to pass in the full information, okay, that we enhance our experience. Okay, so the full information include the case title, the evidence, plaintiff, which is the one that actually filed the case, and the next step, your case has been filed and is now pending. The system owner, you can, not the system owner, but you will start, you can start the trial and start the trial, and AI agent will debate your case. All right, so that is the next step right there, and that is it about this tool. You see the format, or see how we go about it: the description, the schema definition, the execute function, basically what it is expected of the function of the tool to perform. So the performance, that is what it is there. Okay, now we're gonna do a read query for read operations. Okay, so in this place, we want to do get case. All right, and in getting a case, I'm gonna do this for now. Let's do this. Okay, so this is what this tool does. This tool gets detailed information about a specific case by its ID. You already know the story, and then it accepts a case ID, which is a string, a number, or a big int. We convert it. So we come here and say case ID, then we say Zod, okay, all right, Zod.union, and then we say these are the condition or the various types of value that we're expecting that a case ID can have. A case ID can be a string, it can be a number, it can be, a big int, it will, all of that doesn't matter, but any one of these will be converted to the appropriate format. And then the describe function, which say the case ID to query or ID of the case to retrieve anyone you want to use. So these are the information. This is what is required, and this type validation is very nice. It just makes the development process more precise. And reduces the chances of hallucination. Okay, so when the AI already knows exactly what kind of data is expected of it, it doesn't go about doing a lot of guesswork. So at this point, you want to do a try catch. All right. If there is any error, you know the drill. You just return the error well formatted. So otherwise, this is where we spend our time. We want to get the ID first, the case ID. You say case ID, if the type is a big int, you just return the case ID because that is the format that is to be sent into the blockchain, into the smart contract. It understand big ints. And then otherwise, you should convert the case ID to big int. All right. Now that we have big int, we can grab the case from the blockchain. And once we grab it, and we then return the case. So here, once the case is gonna be another object inside of it, and to have this bunch of records. Okay, right. So it's gonna contain the case ID, making sure that is in string is converted from big int to string for JSON purposes. This is the plaintiff or the one that filed the case. This is the case tied to the evidence hash, and the file that. Okay, and then the status. All of these were designed to make to format it in such a way that it's easy to understand. So there we go. That's all that we need for that tool. We need to create another tool again. Okay, so I'm gonna move a little bit further. All right, so we have something like this. This is a tool for get user case. So it just get all cases filed by a specific user, and this is how we validate the inputs. Because we will need the user's address, and it must be a string, it must be optional, and user address default to the connected wallet address. So in case you're not passing it, we know what to do. Okay, so that is what is going on. All right, so that's for validation, and then we need the execute function. In executing this function, you're going to need this, of course. And the first thing you want to do, you want to check if there is a currently connected address. So if this was passed, if it has record, otherwise you use the default value as a currently connected wallet address. Okay, now we want to check if there is no address, then you should return an error, because it means that we can do this. We need an address to query the blockchain, whether we're reading or writing to the blockchain. It is all important that we have we have both we have the user address or the caller's address as part of the objects that are sent to the blockchain, or the records that are sent to the blockchain to retrieve or write to the blockchain. All right, so we got that. Now the next thing is to do a try catch, and of course make sure that you format the error correctly. And then here is where we do all the doables. So first I want to grab the user's case IDs. This is it. You get the user's case IDs. Now for each case ID, in case IDs, okay, of case IDs, you want to get that case ID. All right, once you get it, you want to push it into this cases array. All right, here are the things that you're going to be passing along. So the ID, you're passing case ID, which is a string, okay, the string version, and then you pass the big version, the title, the plaintiff, the evidence hash, the file that, and the status. Okay, those are the records that you're going to be passing, and all of them will be available in these cases now. Great. Once that is successful, you want to return a message, captures all these things that you've been seeing. So success is true, number of fault cases with that case length, then you pass in the case and say found cases, filed by the address. Pretty simple, pretty straight to the point, and very fantastic. Okay, so but by all means there must be a return statement. Okay, there must be something that is being returned. All right, so that is how you get the tools rolling. All right, so what other tools do we want to work on? We want to work on this time around. I'm just going to paste this entire tool and just explain it. Get total cases tool. So this tool gets the total number of cases filed in the system. You understand? It doesn't need any form of parameters, so that's why we put in an empty one. And you, for the execute function, we're not passing any parameter either. Just call the total number of cases and then return it as an object. So I just it straightforward. Right now, these are trial management now. Okay, trial management, write operations. We say owners only. So owners could be either the deployer or the plaintiff, which is the contract, the case owner, or the one that filed the case. All right, so I'm going to paste this here. Make some. So this is a start trial tool, and it starts a trial for a pending case. Only the system or case owner can perform this action. All right. And then it requires the case ID, which is either any one of these. And then we do the case ID to start the trial. So this is the description. Now let's do the let's grab the execute function. So to execute this, okay, to execute this, you want to check owner. Let's come to this check owner a little bit. You require wallet. This is making sure that wallet is connected, and require owner means that, check if the wallet is connected and the owner, and there is an owner in that wallet context. Okay, so the operation requires system owner privilege. So we can just say something like, because at this point, it's not just the system owner, but whomever is connected. You understand that? So this is not about the system. So requires a system or case owner privilege. Only the contract or case owner can perform this action. I'm just going to put that there. So when we come here and we see we require check owner, okay, and then if there is an error, we should throw the error. All right, so we can move forward. Do a try catch now. So we need to pass this. We just need to throw it this way so that it rethrows the error, so it propagates to simulate trial or other callers. So because there are other callers involved here, we want to throw it this way so that it can propagate. All right, so that's one thing we want to do. And of course you want to get the case ID. So the case ID, you format it, you make sure that it's in the right order, then you call the blockchain start trial function. All right, once that succeeds, you just return this information. I'm going to format it a little bit more to be in tune with this. Okay, so transaction trial started for case ID, and then next step, the trial has begun. AI lawyers will now debate the case off-chain, and the verdict will be recorded once completed. All right, so that is what is going on in the start trial function. Now we need another function to record verdict. This recording of verdict seems to be the most parameter intensive tool. So what does it do? Record an AI generated verdict for a case in trial. Only the system or case owner can perform this action. And then, originally I designed this entire thing for the only system owner, but now I'm just adding that little changes. Okay, so the case ID needs this, comply with this format. The verdict type can either be from minimum of 0, maximum of 3, so to match the various enums that were part of it. And the description is type could be 0 is guilty, 1 is not guilty, 2 is settlement, and 3 is dismissed. So that is what is going on there. And then the reason is a string, and this is how you describe it. AI judge reasoning for the verdict. And then the boolean, is final is boolean. Okay, describes whether the verdict is final if true can be appealed. All right. Okay, so at this point, we then need the execute function. All right. So for the execute function, you want to check to make sure that the owner, this owner has permission. That means you have the permission to work with this. You see, one of the things that we are grateful for is that this requiring owner does not enforce that it must be the owner of the smart contract. Even though it is written in this way, it isn't really about the owner of the smart contract. Okay, so you know, but we'll get there. If there is any issue, we'll come and resolve it. Make sure that case owners and case owners and um, contract owner or deployer can both get along with that contract, with that operations. Okay, so we need a try catch. Okay, you want to format this error here. Now, you want to say, in a nutshell, this would have been a lot simpler if it's just like this. But first of all, you need to get the case typing to make sure that it's in um, the right format. Then you want to call that blockchain function record verdict with these parameters, and at the end you want to map the verdict type number to human readable names, because when the verdict is coming, it's coming as a number. Understand that we don't want it to be as a number. I'm going to bring this here. It should be either one of these, and then this time around, okay, the number will correspond with whatever value that is here. And also I want to improve the response formatting to this. We see verdict recorded for the case, and the verdict here, the type is the verdict name, the reasoning, and it's final. So this is the record by the verdict, and the next step is this verdict is final and can be appealed by the plaintiff if desired. This verdict is not final. Additional proceedings may be needed. All right, so that is what this tool does in a nutshell. Okay, so let's see what other tools we need. Verdict query tools. All right, so we see verdict query tools. We're gonna make use of. I think at this point we don't need too much explanation. I could just use this function and just tell you what it does. This is the get verdict tool. Description is to get the verdict detail for a case, and the case ID has to be either one of these, and then you make sure you convert that to big int, and then you get the case verdict from the blockchain. You say successful, and you align the verdict format in this way. The case ID must be a string, verdict type specify, and then the reasoning. Okay, you also specify. Okay, and the timestamp. All right, you need to convert that to number, because when it's coming from the blockchain, it's a unique timestamp, and it isn't very front-end JavaScript ready. So you need to multiply it by 1000 to give it an extra triple zeros. Okay, and then at this point you can convert it to an actual date object. Right, so that's what is happening here, and its final is whatever value it is. We know that is a boolean. That is what this function, this tool does. It's very funny how they are just renaming renaming this LLM thing is just renaming what we already have. Basically, these things are just functions, and it's saying two, like it's something new. it really isn't something you just function. Okay, and let's place this here now. This is another query function to check if a case has a verdict. Okay, and if the verdict has been recorded on the blockchain, right? It needs that case ID standard, and you need to convert this to begin standard. You need to make sure that you need to check the blockchain if it has a verdict. Okay, query that, and then return success case ID in string as verdict, which will be true or false, and message if it has verdict. If the case has a verdict, it's going to return this case has a verdict recorded. If not, say no verdict has been recorded for this case yet. And that is it. Straightforward, simple. All right. And I think we have two more stuff here that we need to resolve. Okay. Two more tools. So these are the appeal operations. These are write only. So appeal operation. So we need a tool for appealing the case. Now this appeal tool is quite long, so I'm going to break it down and guide you on a step at a go. So this is appeal to appeal a completed case with a final verdict. Only the plaintiff or system owner can appeal their case, can appeal this case, can appeal the case. Okay. All right. So this is standard. Case ID is required. All right. And then you need that execute function is where we do the rest of the things. You want to make sure that because this is a read operation, you want to make sure that the wallet is connected. Standard. All right. And you want to format the error down of the day. So now you want to convert that to begin and appeal the case. And after you've done that, you want to grab the case record on the blockchain just to confirm, of course, and you want to check if it's not showing, if it's actually completed. All right. If it's no longer completed, right? So say if case the status is not equal to completed return, cannot appeal case ID case is case status, and then but must be completed to appeal. So the case must be, after you appeal here, then we are only confirming that it's no longer in completed mode, but it's been appealed. Okay. And if it is appealed, then want to check. I want to go to this next step. See, this next step is checking if the owner of this case is not equal to the. This is not necessary. Okay, this is not necessary. It can be the system owner, like the way we designed it. So we say case plaintiff. Only the plaintiff can appeal their case. So we can decide to keep it this way. Okay, we can decide to, but others can actually, the system owner can actually appeal the case. So we can keep it this way, or we can just remove it in total. So remember, this we only, I think I may have made a mistake. This is not where we actually appeal the case. Okay, this happens before we even appeal the case. We appeal the case at this point after we verify all these things. Okay, we're verifying that the case is not in completed mode. Is in completed mode. And we're also verifying that this case ID of the plaintiff, is not, but I don't really fancy this. So I'm going to remove it because it kind of goes against how we designed it. Okay. So I'm just going to leave it at, simple. And then I'm going to improve the formatting of this. All right. So this is how it's formatted. Appeal, appeal file or case. And then you specify, you say your appeal has been filed. The system status is now appealed and will be reviewed. So I'm going to leave this part to you for your own discretion. So you can decide to either keep it or not, but let me keep it that there, right? But it doesn't really impact us much. Okay. So that is for appealing to. Now we have one more tool to put together, and this tool is called System Info Tool. All right, so what does it do? Let's bring it in. So this is a tool, complete the entire thing. So get the address of the system owner, which is the contract owner, and it doesn't require any validation of input because it has none. And then from the blockchain, you get the owner, and then you just pass that information as an object and return it. So that is what it does. Simply, at this point, all the errors that we had have been, they're all gone. Our system is ready for LLM agent to interact with. So in the next part of this video, what I'm going to do is I'm I'm going to walk you through. We're going to create 3 agent profiles. I'm going to create the agent profiles that will be responsible when we're doing case simulation. Okay, so these agent profiles will include a prosecutor, a defense lawyer, and a judge. So we're going to define all those things and use seeing some prompt engineering to make sure that what we are doing is accurate. So I'll see you in the next part of this video. All right, so we're going to be working on LLM agents that will be responsible for carrying out debates in our platform. And I just want to introduce you or give you some um, concepts about the workflow, because this file is very important and determines the user experience of the court simulation. So it's very interesting. So what we have here is, this is a rundown, a high level display of it. We have Rumble Court System, which is our platform. We have a prosecution lawyer, we have a defense lawyer, and a judge. These are all agents. All right, 3 agents. And then we're going to be working with an agent engine, which is Open Router in this case. We'll just do this. So which is Open Router. All right. And we have a debate controller and then a blockchain, storage. These are just various aspects. All right. So these application. So that is what we're going to be diving in and see how it works. To get started, I need to create a new file within this folder. Call it llm-agents.ts. So this is where all the logics are going to be going. The first thing we want to do is that we want to specify an agent profile. Each agent has a distinct personality, role, and communication style. So this creates realistic courtroom dynamics. So to do that, I'm going to use this type. All right, so this is the agent profile. These are the 3 rows and all of those, and also has a system prompt. This is called LLM instruction, personality, which is a description, the tone, which is a communication style, and this argument style. So those things are very important. So for example, we have, this is the profile of a prosecution lawyer, right? So whose name is Alex Chen. Personality is aggressive, logical, detail oriented, focused on proving guilt beyond reasonable doubt. And then tone is formal, authoritative, and persuasive. Okay, style is structured, argument with clear evidence. Okay, there's no system prompt yet for this. We're going to come to that. So in designing the system prompt, you know, we're going to be defining some identity and role. We want it to be very clear, and straight to the point. We want to also define some critical constraints to the system prompt, very important. So constraint will be like, I don't want for every output that this agent spits out, it shouldn't be more than 150 words so that it will not be too lengthy for you to read. This is a simulation, this is an MVP, so it sort of, so want to keep it short. All right, so that is very important. Those are constraints that you want to put. You want to bring in the personality trait into it, and response rule. These are very important traits. Okay, so I'm going to do something similar now for defense lawyer. Okay, and also for the judge. You get the judge. We're going to modify all this thing pretty soon. Okay, so this is the various members or agents that we're going to be working with. So now let's get all 3 agents, okay, defined in one place. Okay, so we're going to use records so that we can easily retrieve each agent. All right, so how do we do it? Say I'm going to be exporting it now. Export const agent underscore profiles, and this is how we're going to do it. I'm going to say record, right? This is what is going to be happening. So record agent profiles, record a passing string, and then you get the agent return. It's almost like mapping in Solidity also. So that is what you use. This is key value, right? So I want to deal with all of this. So the first, I'm going to copy each one of these. Okay, I'm going to come here. So I'm going to copy this and see, right? And want to do the same here for a defense lawyer. I want to do this judge. Hold on. I'm going to do this with the judge, and I'm going to delete all this, right? All right, so what is this saying? System prompt is missing, of course, it is missing. We'll come back to that. All right, system prompt is going to be the last. I'm going to say name, and I'll give it an empty string for now. We'll come back to fix all that, and so that there will be no error showing anywhere for now. So what are we doing for system prompt? we're going to be using this backtick expression to give us enough room to really create something well structured. All right, so I'm going to also improve the personality. All right, so the personality, I'm going to improve it. So is not going to be this is not going to be a little bit more refined. Okay, aggressive, logical, detail oriented, focus, improving guilt. All right, beyond reasonable doubt, then say confident in evidence presentation. So I'm just improving that. The tone, I'm also going to be improving the tone a little bit. So the tone will move from just formal authoritative and persuasive to also use legal terminologies appropriately but accessible, right? And the style, I'm going to also improve it so that our agent will be sharper. I'm going to say you should also have, it should be direct, outside of being structured argument with clear evidence citation should also be direct and confrontational when necessary. All right, so with that said, um, we are going to bring in the prompt, the system prompt. So for the system prompt, this is what we're going to say. I'm going to be breaking this into multiple roles so it will be easy. So you are Alexander Chen, a highly skilled legal expert, specializing in criminal and civil prosecution. Your role is to present a compelling case against the defendant based on the evidence provided. All right. Now we need to bring in a constraint. A critical constraint is that keep all response under 150 words, be direct and focused. All right. And not only that, we also want to bring in personality trait into the prompt. I want to say that your personality trait is aggressive yet professional, meticulous, attention to details, logical and analytical, thinking, persuasive, communication style, confident and assertive. Okay, so this is also trying to help me out. Then send it, Okay, so I'm just going to bring in the rest of this because I don't want to explain every single thing all the way. So I'm going to bring in this, the key responsibility that we expect. Okay. So these are the key responsibilities to present opening statement that establishes the case, question witness, and present evidence, cross-examine defense witness, make closing argument that summarizes the case, respond to defense arguments with counter evidence. All right. Legal approach focus on burden of proof, connect evidence to legal precedent, highlight inconsistency in defense argument, emphasize the seriousness of the charge. This project is pretty cool if you're going to be, if you're, let's say you are doing you're in this legal profession, or you're in computer science and you want to do your final year project, or even PhD kind of dissertation and all that, master degree, whatever. This can be a very solid project for you. So just put in out there, and then you put on the rules and all that regulation. So this is the framework. All right. I'm going to do the same. I'm going to update the defense lawyer with more information. Okay. Format this very well, making sure that everything is in alignment. All right. This role is a little bit different. UI Marcus Rodriguez, an expert defense lawyer known for creative strategies and client advocacy. Your role is to defend the client against the charges and create reasonable doubt in the mind of the jury. All right, so this is pretty cool. And these are other constraints and personality definitions. Okay. All right, so now for the judge, I'm just gonna give the judge this information. Yeah. All right, I'm gonna push this in, break this, and that is making it clean presentation. So basically, Judge Sarah, an impartial and experienced judicial officer, your role is to preside over the trial, evaluate evidence, and deliver a fair legal verdict. So that is basically it. All right, and then give it, interesting constraints to make sure that we are in a good flow. So it's time for us to define the trial structure, right? So how would this trial ensue? What should we expect? So I think I should break this into make it easy to navigate. All right. So that is what we want to define now. Each turn, a trial has different turns. So each turn, we want to define how that goes. Right, so I'm going to export a new interface or debate turn. Right, debate turn, we have these three agents: role, the message type, the description, requires response. Could be used later for interactive mode. So like we say, this can be set up in such a way that if there is this require response, can really improve the communication style, and the debate flow within the court room. All right. So, and now I'm going to define some debate structure, because we don't want it to be like on a Wild West, so that although we can set that up, but for this version, we want to define a structure. But if you want a freestyle mode, I think this is where this require response will really come in. But it needs to have a starting point and an ending point. So that's why we're going to be using this. I'm going to update that. It's this one lacks row. I'm going to bring in this. Okay. This one contains all those. We call a judge, which is the agent. The role is a judge and all that. So these are various steps that will happen in the courtroom. There will be an opening statement, there will be an opening argument, there will be an opening argument for both lawyers, and the prosecution, witness examination, cross-examination, witness examination, cross-examination, and then closing argument. So we just made it quite simple, all right? But in real life, it's a lot more complex than this. So of course, you can always enhance it and even make the whole courtroom experience in a whole new light. You can give the agent a lot more freedom to be creative, and you will be surprised how the texture of each case will marvel you, and how each case is debated. Each time we always have some form of a change, and it will be cool if you can, because we're going to be using one free LLM model, but it will be nice to see how you can integrate multiple models, and it's very easy to do with my current setup already. It's just that there is not a lot of good LLM, agentic free model right there on open browser. So I just stick with one, but define different profiles for them. Okay, so this is the debate structure. After we dealt with the debate structure, all right, we want to define the building dynamics, the dynamic prompt. So we want to be able to give each agent, a context about the case, the current case, and previous terms. So what was said before and then what is being said now. So we need all that together. So that is what we're going to be working on next. Okay? And to do that, I'm going to create this function. This function is called generate agent prompt. We take an agent profile, a case title, an evidence hash, and debate history, which is an array basically of agents and their messages. Okay, and we expect this prompt to return this prompt that is to be generated to return a string. All right, so first thing I want to do is define the case history. So case history, history context, sorry. History context is going to be based on this debate history right here. And you want to make sure that it is actually greater than 0. Okay, I want to make that little difference matters a lot. And if it is greater than 0, you want to see, you want to give it the previous record. Okay, you want to say here is the current state of the debate, and then you give it the format, a debate history. We're going to come to that. This is a function we're going to work on, and you pass in the debate history so it will format it and you break it into several lines. Otherwise, you just return an empty string, so it doesn't have any debate history. Okay, and for the format debate history, I'm going to paste this function below. So this function will take debate history and then is actually referred as tons here, which is the array of agent and message, and then it will map or loop through it and get the row, which is the name of the row name, which is the name of the agent. So just grab the agent profiles and pass the agent dot agent to give us that specific agent. Then we'll access the name of that agent, or we just do agent. So after we get that row name, we make sure that we format it in this way, the role name of that agent, and then the message. Remember that an agent profile, the role has a definition, a defined role here, okay, which is either something like prosecution, but the entire agent itself is also bearing the same name, which is prosecution. So that is just a difference issue to get there. All right, so at the end of the day, this is how you format it. All right, so since the formatting is up and running, the next step is we want to define the case information. All right, the case information. All right, so this is the case information. I'm gonna break it down. We have case information, and then we can, okay, and just format it for ease. Okay, this is how it goes. So this is how you define the case. I don't think this is very necessary for me to do. Okay, all right, so this is a case context. This gives the LLM, the agent, how the, an idea about this case. All right. And this is the case. This is basically what we're going to be feeding into the LLM for it to give us the best, response. We just return the case context. That is what we are planning on doing. Okay, so this is what we're going to be giving the LLM. Fantastic. So that is how you build, you generate case agent prompt, right? Fantastic. Okay, so now I want to do a simple mock simulation. This mock simulation is going to be, it's just going to be based on development purposes, okay, for testing and development, but there will be, you can, of course, advance this, enhance this, and make it much more robust, much more data. So there are better ways you can approach this and make it even more dynamic, than what I'm going to be doing here. Okay, so I'm going to come here, I'm going to create a new function called simulate agent response. We're getting any one of these agents and we're expecting a string to be returned. So we're going to set up a timeout. All right. So timeout to help us manage the response times. Okay, and we're going to get the agent, each agent by name. All right, so we'll grab this agent name. All right, and we want to say, I want to do this if agent is actually the prosecution. Okay, then this is what we want the response to be like. You get it? So say your honor for this prosecution, blah blah blah, evidence and all of that. Okay, so that is what we want to do. Okay, and not only that, if also want to do for a defense, this is just for dummy purposes. Okay, and also want for the judge. Okay, and the end we want to return a string. So these are just some simulation responses. It's at this point it's not very important, but it gives us an idea about the flow of arguments within the courtroom. All right, so now that I have that, I'm going to close this now and let's do a more important function. And this is actually calling the LLM agent. Okay, so this is going to be very important. This is how LLM agents are going to be called. Okay, so this is the function responsible for that. I have an agent, I have a prompt, I have a system prompt. System prompt and prompt, they are different. Okay, they are different in the sense that a system prompt gives like a background understanding about, or a structure. You give a structure or a personality, constraints, and all those other foundational guardrails, or to an LLM, model, so that they will respond within that framework which you are giving them. By a regular prompt, which is basically called a user prompt, is feeding a new information into that structured framework of prompts that you're providing. So not like you define a foundation and then you put something inside, or you have a building and then you put stuff inside the building. The things that you put in the building can only be within the shape and size of that building. It can't go beyond that building scope. So that is the idea there. So we want to make sure that we have the API key. You grab it from the environment variable. Please, if you don't have your Open Router API key, I will really recommend that you get one. Okay, very important. And you want to make sure that that API key is present. All right. So if it is not present, because it's very important, so LLM will warn you that Open Router key, not configured using simulation. So this is very important. And then it will return the simulation, agent response. All right. So if that succeeded, we want to move on to the next phase, which is to log out the LLM calling. Okay, LLM is, say calling LLM for agent during phase and then blah, blah, blah. All right. So this is basically a shared function. So it's going to be shared among the three agents. We want to do try catch. Okay. And in the try catch, we want to quickly, return this if it fails. All right. But if it doesn't fail, we want to do a fetch call. Okay, let's do a fetch call to Open Router. So which location, which endpoint do you make that call? You make that call to Open Router endpoint. So you go openrouter.ai/API and then v1 version and then chat, all those things. That is good, So, but there are other things that we need to add here. Okay, method is going to be post. So we have method is post, header is content type, application authorization is that API key that we just access, which is a bearer token, and HTTPF ref. You want to specify your own website, which is whatever website you want to do, or you just give a dummy one. Okay, and then the title is Rumble Court AI. So those are the header, records that you need to pass, and you need to also pass a body. Okay, so this is the body, and these are the things the body is going to need. We want a model. All right, we're using this model because it's free. Okay, this model we're using is the same thing as the one in our environment model, what's it called, variable. So it's the same model right here. I'm just putting it here in case it's crazy and could not access this one. So that is one model. We want messages. These messages will be like context that it should be aware, like previous messages that has already happened. All right, and the role is system, and the content the content we want to give it for this one is going to be system prompt content, and then this is the user prompt also. So those two, these are the two prompts: message, the system message, and the user system prompt and the user prompt. These are the two prompts that we need to pass in, and we're getting these prompts them from here. Okay, after we pass in the prompt, we want to also pass max tokens to be 400. Okay, and temperature This temperature is going to be dynamic. So if it's agent, if I'm actually doing a specific agent such as George, it should have free. Okay, otherwise for the other agent, which are the prosecution and the defense lawyer, there should be around 7 because George should be more deterministic. Okay, so that is things that we're doing here. Right, so this is how you make that call. Fantastic. So the user prompt, remember, will contain all those messages, previous messages that had already happened. So it will have enough context. Meanwhile, this is foundational prompt or system prompt. All right. And then once that is successful, we want to convert this response to JSON. And after that, you want to make sure that it's actually returning value. All right. So if it's not returning value, you should throw a message, an error. And then at the end of the day, it should return the messages. So you call this data.choices, you grab the first member of that member of that array, and you access the message content, and then you trim it. So this is the response that is coming from the LLM. Otherwise, you say no response. Okay, that is basically, it. Great. So I'm going to also bring in this little function here. It's not being used here, but probably going to be used somewhere. I'm using it somewhere. It's not used right now, but I'm going to be using it somewhere later on. So this is called next speaker, get next speaker, which is very important to know who on it is in the courtroom setting. So we're going to see these are all the things that we need in this particular part, and I'm sure that you have a grasp about this courtroom and how important this file is. So in the next part of this video, I'm going to bring everything together. I'm going to actually be focusing on the courtroom context, which is using React context to fabricate things together. After we've done that, we are just about getting close to finishing everything off. So I'm going to see you in the next part of this video. At this point, we want to head to the context file in this folder. Very important file. It's one of the most, if not arguably the most important file, not because it is super important, but the role that it plays, that's what makes it important. And if you mess it up here, it kind of affects the way your application behaves. So especially with prompts and all of those things, we're going to go through it, and it is a large file. Look how long it is, but it's going to be a lot larger than this. Okay, so I want to go and work on it one after the other. All right. For example, I'm going to just change the things, or what you should know about this file is that it is important to keep the context of the court. So you have more, it holds information about the current status or how the court currently is, the records that are there, the information that are there. So it just keeps, the current situation of the court, in memory. Know that the court has multiple components. So how each one of those components are communicating together from both the history part to the history sidebar, the courtroom component, and every other component. They are all orchestrated and governed by this courtroom context. That is where they share information. So anything that has to do with the court is where you have it. First step I want to do is to update this import records. Okay, I'm going to import it because I have other things that I want to make use of. So for example, how to make use of this set wallet and the MCP tools. And here there are two most important things we exported: the set wallet, and not just only the set wallet, the MCP tool itself. Okay, MCP tool, you can see here. So those are those items we exported. They want to make use of it here, because this is the context where we will interact with that. You see that it, even in this, you're going to be making use of this Courtroom MCP tool within this context folder. You're going to be making use of this blockchain tool, okay, in this context script. You're also going to be making use of all these LLM agents and so on. So this is why see that it has a lot of things to do. So what I'm going to do now, I'm going to remove this Courtroom context, remove this entire Courtroom context, and sorry, I'm not going to remove it. I'm just going to add something. Just going to add these interfaces above here. All right, so I'm going to add this and a chat message. I'm going to add those ones, and I also want to add some OpenAI, just an additional block. Okay, this basically is saying this is how a case is. Okay, this is what a chat message is. All right, so we're adding those. I think before we're having errors here because it doesn't have access to this information either. So I'm going to make sure that those are there. And I'm also going to be bringing up more interfaces. This is specific to calling. I'm going to paste it here. And let me explain that. So this is another interface. This is for OpenAI interface. This is how OpenAI basically interact with the MCP and also communicate that to its endpoint using all this. We're specifying role, content, two calls, and then we're actually adding the tools and the two call ID. So the two call ID, what happens around this two call is basically, let me not just explain it now, let's just leave it now, but this is what OpenAI uses to send message to the LLM, and this is also another interface that is used to translate whatever message that was sent. The response of it is structured in this format. All right, just know that when we're sending a message to OpenAI, we're going to be passing the tools that are available so that OpenAI can also know, not OpenAI, so that the LLM can also know which one of those tools that it should call. You understand that? So that's what is happening there. And then this is to call, basically the tool to call. This is how it's structured. And to call execution context, so the to call ID, and because each tool has an ID, there are multiple tools. I think we have about 25 tools. So each tool has its own ID, and then the message here are basically the records or chat history that we're going to be sending along. Now I have this Zod and this Zod type, these two schema. So basically those are the things that we are adding in there. We're going to be updating this Courtroom context. All right, so let's update that a little bit. I'm going to update this, just remove the error. So what is different here? I'm not using this case, for cases, we're not using this case verdict, case with verdict. We're using the one that we defined here above. So this is what we're using here. So we're not using the previously defined one. So that's the major difference you should know. All right, so let's get to the next step of things that we need to change. I want you to we want to look for, um, let's look for these dummy messages or dummy cases. We want to remove all these cases. Okay, we will not need it. All right. So this was only for um example, just for example, because we're not dealing with real cases. Okay, we're going to be removing dummy case. All right, so I'm going to do this. Okay, now the dummy case is gone, and right here, so want to deal with this line and here and this line as well. What we're changing here is, first of all, we don't want this dummy hole cases thing. We just want case, case array, the new one that we created, and then an empty array by default. So we clear that. We also don't want the current case. We also don't want this case with verdict. We also want this. So we change that. All right. So we want to add a new state variable. And where are we adding this new state variable? We're going to add it basically around here. So just around here is owner and set owner. We need that. And we're going to need, let's look for this abortion simulation function. Abort simulation, not abortion. Abort simulation function. I'm going to bring in this function before here. Okay. And then we'll jump into this simulation trial, this big int replacer. We'll replace big int with string. That is what it does. So this is start trial. Let me start spin up this server so that I can show you what start trial, where it is triggered from. Okay, so basically this is where we have the simulate court trial button. You understand that? So this is what triggers a lot of simulation or background process. So we're trying to make sure that this button will behave when we click on it. All right. So in this particular trial, we will be looking for something that relates to dummy. At first, let us work on this. Is this tool called, this is dummy execution tool. You need to update it. It's not done this way, but currently it is that way. That is because we originally created it for dummy purposes. So what we're going to do is we're going to grab all the tools. So we have the Courtroom tool here. Okay, so just above here, before we need to start up, we start this tool, we need to, before we execute this tool, we need to make sure that the Rumble called MCP Tools are assigned to these Courtroom tools. So what is happening here is that we're using this tool name to track which specific tool that is supposed to be executed, and making sure we pass it into this tool here, this tool variable right there. So instead of having all this, I'm going to remove this here, this dummy stops, and to make sure that we ensure that we have tools. All right, and we grab the tool execution context. After we grab that, we get the tool execution function. Okay, as type here, and we're just passing this execution. Just prepare this execution function because this is basically the process of executing the tool and dynamically determining its argument and context. So, and then of course it's asynchronous, then wait for the result. That is what is happening here. And then checking, you're checking the result status and seeing if it can be iterated, if it is a string, and then return the result in a decent manner. So this executes, now in nutshell, this executes a real blockchain tool instead of returning a dummy data. You understand that? So this function is very important. It helps us to execute all the tools that the LLM is going to be making use of. So we still have a lot to update here. Oh, yeah, this is a dummy trial simulation. We need to patiently work this because currently it isn't good. I'm going to try and remove all this. Okay, this only trial. Right, so that be easy for us to follow. Step one, sorry, you want to set simulation trial it to be what true, because when you click that button you want this to be toggled. All right, and then you want to set that a simulation about ref that's currently called, you want to assign it to be false. So there is no signal yet to abort this case because, for example, once I click this simulate and the process is ongoing, there's a cancel button that I could click somewhere, and then it's gonna abort the case simulation process. If that button is not there, it's quite chaotic, and that's why you should have it. So also going to have a variable for tracking the debate history if it's available. All right, now we'll do a couple of validation checks and see better how you're representing it. So if cases.length is equal to 0, add message and set simulating no case found, and then set it to be false. So this basically is what is happening here. Like there are no cases, right? And when I click on this, it just ends the trial and produce this message. So it's just add the message and shut down the simulation process. That is what is happening there. And it's important that we are able to track that situation. Then there are other situations. So if there are no current cases selected, but there are cases, then it should simply, produce another message. Okay, so the case is no case selected. We need a current case to be able to deal with it. And I think I illustrated it during my presentation of the demo. There's also another situation where the case has been completed. Okay, and if you still want to simulate that case at this point, it tells you that the case is already completed. All right, these are important validation steps. All right, what else? Want to make sure that for a case to be simulated, it must pass. It must not. If the case is not in trial, is not pending, neither is it in appeal, Okay, then you should just give this new message or new warning that invalid case status. So only cases within those three categories can be simulated in the system. So that is another check that is happening. So if all this, passes successfully, then we can actually talk about simulating case. All right. So that is what is going on there. Okay. Otherwise, I'm gonna update this. Okay. So update it and see if that didn't work out. If there's any error, log out the error and also add that error message into the chat, the chat window, so you can get an idea about what possibly went wrong. Okay, so this is what happens. Now, this is where a lot of our operation is going to go. We need to take it one step at a time. So this is, first step we want to do here is blockchain initialization. All right, you want to check for the case state. So you want to see if the case status isn't pending. You want to initially drop this message on the terminal, on the chat interface, and then we just hit the simulation a string that normally shows you, updates or steps that are happening within the courtroom simulation. So you want to make sure that that starting trial on the blockchain is now what is displaying on the on the simulation trail. Let's call it trail. Okay, and within this if block, this is where you want to write another try catch. Okay, so the try and the catch, what you're looking for, they are equally important that I specify them properly. You want to grab the start trial tool from the MCP, all right? So Courtroom Tools, start trial, and you want to check if it has an execute function, because it's important. If there is an execute function available within that object, then you want to execute that start trial. You want to call that start trial function, which we actually call the blockchain function behind the scene. So that is what is going on here. So you say start trial dot execute, we pass the case ID, and yep, the input is basically the case ID. The options are to execution option. So this is the to ID, and this is just optional that will be passed, and this will be executed to call the blockchain function, because if you look at it behind the scene, it is actually the blockchain function that will be operating here. Okay, this is a wrapper function, but when it actually goes to this start trial function, if I open this, find out it's going to be calling the blockchain start trial function. That is very important thing you should understand about MCP. And then at the end, you want a message. When it has succeeded, you want a message of say that trial has started. All right. The trial has started. Fantastic. But if this fails, this is what we look what want it to happen. Want to call this trial error. All right, and want to make sure that we're converting this trial error to string. Okay, and then properly determine which type of error is this. Okay, so does it include already, does it include pending or in trial, and properly relate that information on the chat interface. So is if it already started or it's pending or in trial, we want to say blockchain trial activation skipped because it's ready. So these are for situations where you don't need to do trials, all right? Because the function, the start trial function has already been triggered on the smart contract end, so it doesn't need to trigger a second time for one specific case. All right. So remember, we still have an if, so we want to also add an else here. Else. Else, what we want to happen here if the case is not in pending mode. Simply want to add this message. Case is already in trial proceeding. Okay. This will just make it very easy for whomever is interacting with the system to know what is going on and not be freaked out. All right. So now we're going to jump into the next part after successfully initializing the blockchain. Next part here is to do the AI simulation loop. So in AI simulation loop, there are multiple steps that needs to be carried out. Okay, so for that to happen, we need final verdict, which could be guilty, not guilty, no, or reasoning, which will include verdict. Verdict is either one of these, and then the reasoning string. Yeah, otherwise it shall be null. So this is the final verdict by default. And we want to go through the debate structure. Remember, we created a debate structure earlier on. Okay. So earlier on, we created this debate structure that shows us, how the debate flow in the courtroom is going to proceed. So it contains number of turns, debate turns that needs to take place. So we want to look through all the debate turns and simulate it accordingly. So, but you want to make sure that you're checking if the simulation has been aborted at every turn, at every step, so that if it's aborted, it doesn't continue on. These little guardrails are very important, because when I was working on it, I had to, I went through a lot of things to try to make to put it in this way. Okay, so you want to make sure is simulation aborted. If it's aborted, you just want to see log out that information and then return. So you want to end it there. All right. So otherwise, you want to specify this record, the bit turn, what is currently the turn, which is the object, get the agent out of it, you get the agent profile out of that specific agent. Okay, so we have so many agent profiles. See, part of this is exportable, and then we pass in the agent we want, and then we get the agent profile. Okay, now we want to update that simulation tree, which is more like a notification concerning the stage where the trial has gotten into or gotten to. So at this point, I want to see that the trial is, or the turn, which turned up rule, or which could be a prosecutor, a defense lawyer, a judge, is preparing, you know, certain, the certain message. Okay. So if we go to turns, for example, okay, you see that each turn has a message type, which is opening statement or other kind of statement, cross examination, and so on. So that will kind of update what is going on there and help us a lot. And of course, we want to add message to the terminal to also keep the user updated about the loop process on what is going on. Okay, so two places that these updates are happening, in the chat messages and also in the simulation progress bar. Right, so we have that, just to stop updating. All right, and now that it has updated, we want to generate the base prompt. So remember, we specify the function called generate agent prompt, which will pass the agent profile. Okay, I go back here, you find it, agent profile, case title, evidence hash, debate history. That's what we're passing here: profile, case title, evidence hash, and debate history, so that we generate a prompt for us, right? So great. So I want to do an if else statement here. Okay, so there were some times that we're having issue, the judge was having issue determining or understanding that a case has been completed. Okay, so in such case, we want to enforce, want to inject strict instruction for, the verdict on. So this will help this ensures the judge knows the trial is over and must decide now. All right, that is very important at this step. Okay, so the prompt, we're going to just attach or append this into the prompt. Say system override, final phase, the trial has concluded, all evidence has been presented, you must now act as the judge and, issue the final verdict. So this will only be applicable if the agent in turn now is the judge. Okay, yeah, so if it's not the judge, it's not going to be applicable. So we're going to check if the abort flag, we want to check the abortion status of the case before we call the LLM, because up to now we haven't called the LLM, we're just arranging things. So I'm going to check the status. If it is aborted, we just want to say as aborted, or returning now, we're just canceling this whole case. All right, but if it's not aborted, then this is where we call that LLM agent. There's a function here, this function here called call LLM agent. This is where we make a call to open router with all those descriptions, and then it's going to return a feedback to us. So let's just call open router right here. So now we're making use of that prompt, passing the agent, okay, passing the prompt, passing the agent systems prompt. So this is exceeding number of prompts, so we're going to remove that. In fact, we want to make sure that we check that, after we make the call, after we call the LLM, we want to check that, abortion flag or status again to make sure that before we before we proceed, that it's still on good posture, because you don't want to continue with the simulation when the user is clicking about cancel, cancel, cancel. You understand that? You just want as quick as possible to terminate the case and let the user breathe. You understand that? So if that is successful, we want to add this debate history. I'm going to push it into our history. Want to push this debate record into our this thing, what is it called, into our debate history, because this is going to be running on a loop. You understand that? So this is running on a loop and not just one case. So it's going to be running on a loop, and that will create a conversation history. Okay, and we're going to also check this abort states, for the simulation again. And at the end of the day, you want to add one specific message. Okay, one specific message, you want to add it to the message tree. So I want to say content is what this profile name, agent, and the type of the message, and then the response. All right, so you pass in to that message track. So this message track is different from this debate history. Okay, this debate history is not really it's not there for public display. You can't see it on the interface, but this is the one that gets displayed on the interface that shows the user what is currently going on. All right, so if it's the judge, all right, at this time you want to extract verdict. So this extract verdict, so let's extract the verdict. Okay, I'm going to define the function here. I think I should define it above this. Okay, extract verdict. All right, extract verdict from response. So this is judge response, pass a string, and the verdict can either be guilty or not guilty, and then also should provide a reasoning string. All right, and we're gonna do this. I'm gonna say upper response, which is to convert the judge's response into uppercase. All right, and you also want to make sure that you have this verdict assigned to a variable here. All right, so you want to check first if it's not guilty. This is the first priority. So in checking if someone is not guilty, is how you do it. Does this upper response include not guilty, or not dash guilty, or verdict not guilty, or acquitted? Any one of those things, if it's neither. If it's any one of them, it should just be not guilty. All right. There's a reason why we're doing it like that. Else, you're checking for what? Guilty. Else, if if it has anything such as guilty, specifically, then you want it to be what? Guilty. All right. And then you want to return the verdict and the reasoning. Okay. So this function, which is the final verdict in this place, that's how we extract the final verdict from the judge's response. This only happens if it is the judge. If it isn't the judge, it ain't happening. Okay. All right. So afterward, we want to proceed and say, I want to check for if the abort button or the cancel button has been clicked again before we render any form of judgment, because so long as the judgment is not written on the blockchain, it isn't over yet. Okay, so the case can be repeated so long as the judgment has not been recorded on the blockchain. So we're going to be doing a little bit of a delay with abort checking. I'm going to say create a new promise and do a check interval, which is 1 millisecond each. 1 millisecond each. It's not a second, and that is how we always check. And for every 1 second, so we're using set time interval and set timeout together to check the case the simulation has been aborted. This is important. I know why I'm adding all these abort steps in all this. I'm sure you can actually do better than this. Okay, so if you're doing better than this, so you can formulate a different way of doing this in a more cleaner way. But because I didn't have much time and I didn't have to finish up this, I left it this way. Okay, so you can make improvement there and see the best way to handle it. All right, I'm gonna actually add that abortion flagging again. Okay, is simulation ref current. If it is true, that means it has been aborted, but if it is false, it is it. Okay, so at this point you want to do that check again. So this is the last turn and you want to do it again here because we're part of that loop structure now. This is outside of the loop, and if everything is all good, no abortion is happening there, just mentioning the word abortion is just not just feeling right in my mouth. Fortunately, that's what it is. I will just click cancel. All right, so this is verdict recording. So if the case was never cancelled in all these steps, then it should give us this message on the chat terminal and say trial completed, and then provide you with the next step, which is the final verdict. In doing the final verdict, some things we should take note of. You want to make sure that the final verdict, before now, we have this error above here. Yeah, we'll find it out. So we had this error that time, but I think it's no longer an issue. So we want to make sure that if it has, this final verdict. Look at where we extracted the final verdict here. That final verdict has a verdict. Okay, if it does have a verdict, then we are going to do this. We're going to set the simulation progression or progress to recording verdict on blockchain, right? And you want to add that message here. Okay, you do know that um, JavaScript is not like the perfect ecosystem to do LLM based, AI based, agentic based operations. So, but JavaScript is doing pretty fantastic when it comes to this MCP tooling thing in this realm. But if you're going to be creating an AI service, you want to go into Python, okay? You want to know Python, you want to know things like Crawl for AI, Crew for AI, LangChain, LangGraph, ChromaDB, RAG systems, and all of those sort of things. You want to know scraping and document processing, different kinds of things, embedding model, agentic model, blah, blah, blah. You want to bring all those things, knowledge graph, and so on, and long-term and short-term memory, a lot of those things. And the best place to do that um, is with Python. So that is why, you know, hopefully, God's grace, in my subsequent tutorial, I'm going to be bringing something around that area, which you can see the entire pipeline of AI, engineering behind the scene, maybe featuring blockchain, and so on. So when it comes to blockchain, Python is not like the home for it. It's basically the JavaScript ecosystem. So, well, we're good. We're good. We take it one step at a time. At this point, you want to do try catch. You want to catch any issue that has to do with the verdict. I'm going to do this here. Okay. And this is a message prior. Pay to record verdict. It could be for any reason, so you just want to put it there. All right. But if but that is after you've done this trial, this check, you want to check the verdict type map, is it guilt or not guilt, which is 0 or 1. Okay. And then the verdict 2, you want to access that verdict 2 from the MCP tools. Okay. Now once you get that, you want to ensure that the verdict 2 has an execute function, just a safety check, even though we know that we designed the execute function on it, so want to make sure that it's there. And then before we call that function, okay, that tool, call it this way by passing the await record verdict.execute, pass in this object, which is one of the things that is going to be needing case ID, verdict type, reasoning, and its final, which is true. Reasoning is this, and the verdict type is actually based on guilty or not guilty, and then the case ID, which is a big int, right? And this simulation verdict, this is the two call ID. This is optional, but we're just passing it, okay? And then at the end of the day, of course, you want this to have its own special message, all right, that it succeeded. The verdict recorded on the blockchain if this was successful, because this is a blockchain to call. So it's going to be calling the blockchain. I want to also add that these, provided that you're working with LLM and you're going to be working with LLM in this format where all the interactions are done mostly on the front end side. Of course, you can also do this on the back end side. Java, you can actually do a lot of things with JavaScript alone. All right, I must bring that in. But what I'm saying is in building LLM services, not in consuming an LLM service, because um, the JavaScript world is very good at LLM service consumption, but not in LLM service, or AI service consumption, not in AI service development or creation, or building. So you build an LLM service with Python or stuff like that, or you consume an LLM service, smoothly with JavaScript. Okay, so those are just some things, some revelation you should add into your pipe. All right, so I want to load users cases, and I'm going to come to this, you know, which is very important. So this is for every 2 seconds or so. You want to load users cases. We don't yet have this function here. I'm going to bring it in. So we need to come to this beginning of this function, courtroom provider. Here. Okay. We want to also make sure we import is connected. Okay. Because that is why we're having this. Okay. We fix that. Let's create this load function, but let's look for a place to add it. So this just below here, we're going to create 2 functions. Okay, these functions are very important. So the first function is to load users cases. All right, so I'm going to do this. Let's come here and let's generate dummy data, for example. Okay, I'm going to confirm this. So basically around 3 cases has been, these dummy cases have been created. So if I come here, get case 1, all right, contract breach, and let me see this. I have 3 cases. Okay, onto the courtroom. The cases are not appearing here yet. All right, so that is what we want to fix. I want to say load user cases, user ID or user address, and if you want to load the user's case, you need their address. That's what it is. You do a try catch, okay? Do a try catch, and if it fails, there you go. This is the issue. All right, so fail to load users cases. Otherwise, you want to grab that tool, user case tool, from the MCP Courtroom tool, and you want to do some checks to make sure that this tool has an execute function. Is a tool like this and has an execute function. All right, so, and if you verify that, then you want to make that call to grab the user's cases. And this is how you do it. You simply pass the user address and this optional parameter, and then the result that comes, you are basically checking the type of that result. Okay, if it's an object, and case in result. So this is supposed to be cases. Okay, so when you grab those cases, result.cases as case array, pass it in here, and then you set the case array, and then you log this thing off. So this will load the user's cases. So also want to check ownership using the same pattern. When checking ownership, do get owner. All right. So we're making use of this. We're making use of this blockchain what's it called, function now called get user. Okay. So I'll say get user, and we check if this user is equivalent to the owner. Otherwise, if it's equivalent to the owner of the or the deployer of the smart contract, you're going to see is set its owner to be what this user is user owner. Otherwise, you just log it off as false. All right, so that is cool. But now we need some use effect to do an initial loading of this record. So I'm going to search for where this tool is, which is here. So right here, I'm going to do a use effect that before, when this page is being loaded, what we want to do is, using use effect, I'm going to set the wallet context. And if you remember anything about the wallet context that we define here, that it needs a connection state, it needs an address, and it needs an owner or the deployer of the smart contract. So we pass in this thing is connected, the address, or if it is not, and the connection status, the address, which could either be a string or no, and its owner, which is a boolean too. All right, you need that. And you also need a second use effect. This use effect, what it does is to load user's case, check ownership, status as well. And if a user is connected, has connected their wallet, otherwise you just set those things to empty state. So there's still some errors here, especially with this process command function. This whole place needs to be revamped. All right, so let's revamp it. All right, so it is just about better to clear it and work with it step by step. I'm going to try and clear it and help you follow along. Okay, so I'm going to clear it from here. Down to here. See, so this is not going to be dummy, the dummy one anymore. It's going to be real stuff. All right, and we want all this command user input. Okay, so the process command, the user input does an input a string. You trim it to check if it is empty or not. You understand that if it isn't empty, then I'm going to actually clear up all this. So we're going to set its processing state. Remember, its processing state, these are part of the simulation progress. You understand that? Okay, so what is going to be happening? You're going to be seeing is processing. Sorry, this here shows ready. Processing state, when it's turned through, this is going to turn yellow, and this is going to be on processing. That gives you a clue what is happening within the court. All right, so that's why we have it there. And you can see that the case is now reading, or is now those dummy cases that I created is now actually being updated here 3 times. So that's something cool you take note of. All right, so the user message, all right, this is a user's message, and it's using this chat message from open, the one that we defined above the types that we initially defined. All right, so this is what a user message is like. All right, and you want to add that message here. Okay, so you add that message. So this is a user now typing a message on the terminal. So for example, when I type something, hello, you understand that? And then it goes on to give me a response. Say, I don't understand. You say, hello, I'm a demo assistant. So it's still not feeling fine. So we're going to work on it, okay? And when we work on it, it's going to be giving us a good response. But for now, this is what it means that about processing commands, okay? All right, so at this point, we want to do a try catch. And in trying and catching, we want all the assistants, all right, say response for the await call assistant. This is a function that we haven't yet created, and we need to make sure that we create it. And now this call assistant is a very long function. Okay, it's very long. I have to tell you that, but it incorporates the know that the assistant is basically a different agent, right? It is different from the other agent that we had previously created. Okay, we need to create that agent or assistant for two. I'm gonna come back here. I'm gonna put to do. Okay, so we need to create this. This is very long. Please, warning you. This is very long. Okay, we're gonna be jumping between functions, so you need it to bear with us. But this is for your own good. If you understand this, it's for your own good. Okay. I'm just going to close this simulate function, break it down. Okay, come here and create this. So call assistant, what is going on here? In calling assistant, we need a tool called, we need to get all the tools called generate tool definition. So apparently our system doesn't have access to all the tools, right? So this call assistant will be very useful to us because the other one we defined previously has things to do with calling tools when you are in simulation. But if you're not in simulation, it can't call any tool. Okay, so this is a general purpose assistant that knows how to call tools. All right, so this generate definition is another function that we need to create first before we even start thinking about the rest of the application. I'm going to come here below here. I'm going to create a new that function called generate definition. Now in generating definition, we want to look through all the tools within the Courtroom, the MCP tools. So we have a for loop, which is looking through the object entries of the Courtroom. You know that the Courtroom is actually an object, big object that has keys and values. Okay, so like this get connected wallet is 1 2, which is a key, and this 2 record is the value. All right, So that is what is going on here. We're going to extract all that into a defined set of tool name and a tool definition. And you want to check for some things because each tool should have a schema. So if it doesn't have an input schema or a description, then you should want that tool definition skip the tool name and say that missing schema or description, then you continue. Because if you're going to be giving an LLM a set of tools, they need to have a description and also a schema. You understand that to verify or validate the argument or parameters that are being passed in. Now you have the schema. Call on these two the schema as unknown as two schemas. You need to pass this unknown first to disable any crazy stuff, and then before you pass it again as a tool schema. So this is the schema of these two because we are looking through all the tools, so one after the other. All right. So we want to make sure that this schema, there's a schema, and the schema has a definition. So you're saying that if it doesn't have a definition, the tool definition skipping to invalid schema structure. So schema structure is very important to us. And now we need to do some ZOD, we need to extract some of those information. So we're extracting the ZOD definition here, the properties. Okay, the properties will be, let's look at a simple tool that has like this one here. Properties of this two input schema will be this case evidence, case title and evidence. That will be like the properties. Okay, so you're going to be extracting that. Okay, I'm putting it inside in a, you want it to be in a what's it called, record. Certain records are similar to how you will have mappings in Solidity. All right, they are similar. I'm not saying they are exact to the core, they are similar, so the string and unknown. So when you pass a string, you grab the unknown value. So each property has a title or a name, which is definitely going to be a string, and then the value is this complex, stored definition. So you now the cons required. All right, the ones that are required, you also want to track those things then. All right, so afterward, you want to check if the Zod dot type in a name is equal to Zod object. Okay, because if it's a Zod object, then you can work on it to get the shape. Type of this Zod definition dot shape is actually a function. If not a function, then you should just return it as a function, or if it is a function, you just pass it as it is. So it's an extra protection layer. Here you want to make sure that this shape is of the type of object. All right, so that is what is happening here, because we're going to look through each one of those objects. So this is what is happening here, key value hammer. So for each shape, you want to get the field definition and the field type and the field description. These are just how this is described. The field definition, which could be, this absurd, which is a string, and description. So you have the Zod record, the type, you're saying that the type is a string, and the field description, you're accessing description. So that is for it. So we're going to do some type check-ins. So we want to check the various types that this could come with. So if you field def.type name, which is Zod string, if the Zod string, you want it to be string. If the Zod number, you want it to be number. You want to do the same for description. Or if it is big int, you want to specify it as what? As a string. But then the field description, you want to append this information into it, telling because the LLM is going to be reading all this information later on to make the right call. So at this point, it's going to know that, okay, this is big int, but it's going to be described as a string. And then for enum, you want it to be string as well. And you extract the enum values. After you've extracted an enum value, you want to also give a description that it's an enum, and which is an array, and then you join it as a single string separated with comma. Okay, there's also a Zod union, which is going to be returning a string. Zod option. Okay, so those are those various records. So we need to then arrange the properties. Okay, so it's going to be keys, and then the type is the field, the description is the field description. So this is basically how we design the properties, this. And lastly, if it's not an optional, specifically written optional field in all the schemas, if it's not optional, then it is required, and you want to pass the required status into it. Okay, this is how you, not fully, though we're not done, but this is how you ensure that you're getting you're validating the right types and all of those things. So now we'll go 1, 2, 3. Okay, here I'm gonna push in the tool into the tools array. Okay, in the tools array, tools are defined this way. Type is a function, and then the function has a name, a tool description, and its parameters. The way we defined it is all this, and then at the end of the day, of course, you want to return it to. Okay, so at the end of the day, these tools that we're returning, we have the various, we have a more, this tool will provide like a context for the LLM to have knowledge of how our system operates, or the kind of tools that we have in our system. The general LLM, not the agentic type. The agents don't need this particular this particular definition because they are basically working on a case trial. But this is in case, this entire system management is different. Okay, so this is, you can call it a fault agent. Okay, a fault agent. Right. So we're going to come back to this assistant where we are working on it. Now that we have these two definition, so we need a system prompt. Okay. Now this system prompt is going to be lengthy. Okay. Okay, it's not really that lengthy, but this is the system prompt. Right. And what it simply does is, you are an AI legal assistant for Rumble Court. Your primary job is to call tools, not tasks. You must call critical instruction. You must call tools immediately. Do not ask questions. Do not require, do not request clarification. Mandatory tool calling, user mentions file or case, or the file case. Now, why I have to go this deep is because the model is not that sharp compared to, OpenAI's GPT or clouds, Anthropic cloud-based models or DeepSeek. So these are more lightweight models. Okay, it's not like it's lightweight. So you have to be very constraining to make sure that they follow instructions. So that's why I'm putting all these things. So you just give it examples how it's gonna, create case, call, get case, and all of those things. And my decisions for doing this comes as a result of multiple attempts at trying to instruct the LLM to follow certain instruction. So that is why I came to this conclusion, to put it in this way. That is after testing multiple prompt and engineering it to this point. Okay. And user mention case plus number, call the get case now, showcase 5, call, get case, and then all that. But here, the primary inference rule is, if case title is vague, create a professional title from context. So in other words, I don't necessarily need to type in case title and, case description. You understand that it can just generate, look at what I'm trying to do and generate a fitting title and description. So never say I need more information, act first, explain later. Okay, in one sentence. And then the state of the blockchain of the system. So it's fed with the knowledge that the wallet is currently connected or not connected. Case length, cases length. So it gives it context about how many number of cases that this user has on this platform. And then current case, will be the current case, the title and the evidence, and the status. Okay, so that will be the current case, and the rule, the owner or is a user. Critical if wallet is not connected and user tries to file, say please connect your wallet first. One sentence only. Remember, tools first, talk later. Be a doer, not a questioner. All right, so that is interesting, right? So, but there are some more things that we need to do. Up to this moment, we haven't yet used these two definitions. Okay, so those two definitions will be passed along when we are making the call to open router. So let's move forward. we need to do a try catch here. And in trying and catching, if there is any error, we just simply want to see, okay, if there is no error, then we want to specify a conversation. Now I'm going to put this is a conversation. All right. This whole thing about OpenAI message, let me look at it. We don't need to say OpenAI. We can just say open router. Okay. Open route. So OpenAI, because we're not really using OpenAI. So we're gonna change all that. Open router message. Okay. Hope we can remember where we are. Okay, we're still here. So this open router message, an array of it, you want to pass in the system prompt and the user prompt. This is how you use this conversation messages. Important. So system prompt, user input. Okay. And once you do this, you want to specify these variables. The variable include full response, iteration, and maximum iterations. Okay. And you want to do a loop now. So if iteration less than the maximum iteration, want to try and do and run this process for us. Process is to, of course, you want to first bulk the number of iteration up, and you want to, of course, get the open router, key, which I've already instructed you before, and to get, by visiting open router, website, you understand, and signing up. And if you don't have that, just give you an error message that, sorry, the AI service is not configured. Please check your API key settings. Great. And then the model to use, we have a model to use, but I'm going to be defaulting it. So basically the same thing. This is the free model that we're using. It's totally free on Open Router, so you can use that for your learning purposes. But please make no mistake, this model is not bulletproof. Okay, that's why it's actually called preview. Okay, it's not the best tool, if the best model, if I'm gonna be honest with you. All right, so the request body, we have this information. So request body, we have a model to use, a message, which is a conversation, messages, which are historical message, and then the tools, okay, which are the tools, and then the tool choice is automatic. So we are not defining it ourselves here. It's automatically selected by the model itself or the LLM. All right. And then now when you want to make a call to open router, to make that call, this is how you make the call. You fetch call, and then this headers as before, and then make sure that you have your authorization key here, and then this is the body contains these things. You can just literally just copy this part, okay, and replace this or replace it inside here, but I want to put it this way because it works, because at the end of the day you're stringifying it. All right, so this is body, and after you make that call, you want to check if it succeeded or not. So if it succeeded, it's going to be this. If it succeeded, this is going to totally pass. But if it doesn't, this is going to throw an error saying, you know, you have an error and the API failed and all of those things. You're going to get that message. And then at the end of the day, you want to say data is going to be open router response. Open router response. We convert this to JSON, all right, and we extract the response, which is actually captured within this choice index of 0. Okay, so we grab that, and then we want to say if there is no choice, that means if it doesn't contain messages, it should say invalid open router response structure. It's not meeting, how it should, and I believe the reason why we need to take this thing back from open router to open AI is because this is a standard that was created by open AI, not open router. So because it's created by open AI, this is how open AI will deals with what's it called, this this is a standard approach OpenAI uses. So just about all the models that you're going to be using, we follow this standard. All right. So that's why I'm taking it back to, OpenAI response and also OpenAI message, because that is standard which OpenAI created. And these other LLM, companies, they are also using that same standard. All right. Now, if that passes successfully, we want to extract the message. So as message, and then you want to push it into the conversation history. All right. I'm going to put it here. Conversation history, the role that is happening here is the role could either be system message, user message, assistant, or tool. So at this point, this is an assistant that is, making this response. Okay. And then message or an empty message, and then tool, that it called, or it's going to be calling, something like that. Okay. And the tools we also, and these tools has to be in array. So for example, the model could be instructed to call a tool 5 times, and those tools, each one of those calls are going to be layered within this so that it will be triggered by the model when response comes. So it's going to trigger and call the tool like 5 times or 3 times or so on. So that is one of the reasons why we are doing that. I want to say if the message.content, if there is message.content, okay, you want to see the full response, was defined earlier. Okay, the full response which was defined earlier, okay, right here, an empty string at this point. Okay, these two response, you want to append the message and you want to break it into a new line at the end of the day. Okay, now we have one more step here that we are expecting to detect and record verdict. Okay, so this step is also very important. So whenever, let's look at let's look at that particular function. Let's look at that function specifically. Okay, and let's create it. So we can do it below here. All right. So detect and record verdict. You pass in message content, a string, and which is a string, and it's supposed to loop through it. All right. So make sure that if case is not in try or appeal. Okay, let's put appeal as well, and then appeal. Okay, maybe it's not status, a case status. Appeal, not appeal. Okay, so appeal. All right, so it's not, something is not right, so I'm going to remove that, leave it alone. And so first thing you want to do is you want to capitalize all the content. You want to say upper content message to uppercase. All right, and the entire message being uppercase. You want to check for verdict. Okay, so is verdict message. So you're looking for keywords such as verdict, find the find the defendant, finds the defendant. So situations like this, inspires or notifies the LLM or the watching background process that it is time to render verdict. Okay, so if there is no verdict message, then it should just return void. Otherwise, we want to define a verdict number, a verdict type, which is a number ranging from 0 to 1, like here's a verdict 0, 1, 2, 3. You understand that? So, and give it this definition. And if it is guilty, if the message include guilty and this in upper, and if it doesn't include, it's not guilty. You understand that? So you're making sure that it is just the keyword guilty and not guilty. So you're looking to make sure that you are actually extracting the right content and not something that some user just fabricates. All right. So I'm sure that there's a better way of doing this that you can also try out. Okay. And get it done. So we are assigning verdict type dynamically based on this condition. All right. And then if it's null, you just return what? You just move forward. Okay. So all these guardrails are important. All right. Because you're dealing with an LLM, you want the system to be robust and consistent, and you don't want it to be hallucinating stupidly. You understand that? So that's why we're doing all this consistent check. We want to do a try catch, and if there is any catch, we want to log it off here. Otherwise, we'll come here and start operating. So operate this way. We'll get the verdict tool and make sure that it has this executable, the execute object, okay, which is where the function for calling the record to the blockchain lies. And once you do that, you actually call for the verdict to be what? To be rendered. You understand that? So the difference between what I'm doing now and what we have done before is because in previous times, This is for calling it manually. Basically, the other one calls it within the simulation. That's the major difference. Okay, and I'm not even sure that we're going to be using the both parts together, but I'm just going to show you how important this record verdict is to the LLM process and the simulation process together. And if that is successful, you want to say courtroom context, verdict auto recorded, all right, and then um, we we reload our we reload the user's cases that you get an updated information just like we did before, for the case, a user case as well. So now we'll come back to here. Okay, and now you're done with this assistant, call assistant 2. We'll come back and complete it. So in completing it, we need to make sure that the message dot, if you call on the tools, and it has tools, so that means the number of tools that it's supposed to call is greater than 0, then for each one of those tools it should handle to call. This is another function that we need to create now. Handle to call. Okay, told you that this process is just very lengthy. We just need to be very patient about it, and we'll get to the end of the matter. All right, so we're going to see handle to call the tool. So this to call is very important. And we ensure accuracy handling to calling whenever the LLM recommends a certain number of tools to be called. All right, so that's why it's very important here. So the to call, which is the tool, the conversation messages, which is an array of it. You need this information, and you're gonna need the tool name and the argument associated with that tool. All right, so you need the tool's name and the argument associated with the tool, because a tool is basically a function, and you're getting all the parameters, which are the arguments associated with it. So that is what it is, so that when you're calling the blockchain, you can just pass in that tool without needing to explain yourself. All right, so tool for executing this tool name, and then this big int replacer, remember, is a function that we created before, and it's supposed to turn any big int into a string. Okay, so please take note of that. And we need to do some validation / guardrails. So we'll say if case is an argument, case ID is an argument, and type of the two argument, two args.case is a string. Okay, then you should convert it to a big int. Hold on. Otherwise, if the case ID is a number, you still convert it to a what's it called, a big int. But if it's already a big int, it will not need to bother. You understand that? That's why putting those guardrails. Now the tool output is going to be unknown by default. So this is what the output is going to be like. Of course, it's going to be coming from the blockchain, so you don't know exactly how or the shape that it's going to have. So that is one important step that you should take note there. So we have tool outputs. If there's any error, you want to pass that error to the tool outputs as what the tool is outputting. So that's why we specify it as unknown. Now we want to grab that specific tool. So tool is equal to that Courtroom tools. And then you specify the tool name. Okay. And it will get you that tool. All right. So you want to make sure that that tool is present and it has an execute function. If it doesn't, you want to throw an error. It's saying unknown tool name. So, but if the tool is known and all that, you want to have the tool execution context. Okay, which include the tool ID and the messages. This is just you defining it. And then just like we've done before, you want to say the tool execution function. This is the tool execution function. You're grabbing it. Okay, you're structuring it, sorry. And then this is, are you actually executing that tool? No, this is you defining how the execute function is going to be. It's going to be based on this, definition here. And then this is you actually executing that function, which is basically a blockchain function. And then the tool output is stored here. Once this is successful, I want to say tool output. I want to check the type. Is it an object? Is it an async iterator? So you want to make sure you want to check all those things and go through it. If it's a string, first, and async iterator, you just go through it and ensure that because it's going to be coming as a chunk, you append all those chunks inside the string and assign it to these two outputs. And when you do that, you just, because this could be an asynchronous function that keeps waiting. LLM, they have these streaming capabilities. Okay, so the process could be slow, but if it isn't, this operation still takes care of it. All right, now that is good. Now we'll need a little bit of one more step, which is something called case modifying string. Case modifying string, I'm going to give you an example. So a case modifying string is if you type something, these are various case defined. If you click any one of them, it should, which could be file case, start trial, record verdict, appeal case. Okay, you are trying to modify it to execute certain operations. Okay, because those are like hot keyword. You understand that? So that's what you're trying to do. All right, so case modifying tools, you want to check if it includes this tool name. Okay, let me explain it a little bit better this way. These are various functions. These are various functions or tools from the MCP tool. Okay, so these tools, they modify the blockchain. That's why they calling it case modifying tool. They modify the smart contract. So they require, they require that MetaMask is triggered when they are called. So that's why we're tracking case modifying tools and making sure that our wallet is connected and we have a current address to it. Then once all those conditions are met, we want to do this thing called set time interval. I want to do a try catch operation. So if there is any problem, want to do that here and want to make sure that we set this to be 1.5 seconds delay. Okay, so what do we expect here? If it was a case modifying tool, then we want to wait 1 second after the case that function have been executed, 1.5 seconds. Then you want to call this tool to get the user's updated record, and you want to fire that function. You want to call that specific tool. Okay, so calling that specific tool. So this is user cases, and this is what user's address, and then you're grabbing the user's what's it called, the user's record fresh from the blockchain. And if there's a user's case and type is an object and cases in the user's case, then you just extract all the cases as case array and set it. So basically, this is an update mechanism that waits for any one of these functions that are called to be completed before it fires. So when the try catch is over, you want to format output. There is this function called format to response that is already part of our operation. And from here you can see it right here. It just formats it and for easy display. You understand that as what the purpose is for easy display. So we'll format the tool, and after we've format the output, then we will display it. Normally like displaying it as a stringified JSON. Okay, so if it's a string, it has to be just a string. But if it's an object, if it's not a string, you want to stringify the output and replace every big int. This is a function, a callback function that is run across the string to make sure that big ints are represented as strings that are understandable by regular people. All right, and at the end of the day, you want to push this message to the message array, conversation array. All right, and return the formatted output. Hey, that's a lot. So that is what handle tool is doing here. And now that we're handling tools correctly, we want to provide a situation for breaking this loop, this reasoning loop, because this reasoning loop is the process of both is thinking, is carrying out activities, is calling the LLM endpoint and doing all those things then. So it needs to once the message, once we get the message and it's complete, what we want to do is to stop this while loop that is running here. You understand that? That is what is happening here, so that we don't have to get to 5 iterations. We just need to get it to complete. So at each time that you send a message, you speak with this LLM, it's going to try to accomplish the task in the first try, or whatever you want it to do is going to reply in the first one, provided that there's the conditions for successful interaction is there. Example, you need a good network internet connection to be there. All right, you need to make sure that the model that you're using has what do you call it, is if it is you have enough token to sponsor the operation so that it will not fail, and and every other conditions that ensures that a successful response is given to you are met. then it will just go on. You want to check if these are another gathering. So you want to check if there is no full response. You want to say, I've received your message but couldn't generate a response. Please try again later. All right. And then finally, you want to return a simple output. Now, before I conclude here, I'd like to raise something. Okay, so this break here, this is where I'm supposed to end the while loop. So the while loop ends here. This part is outside of the while loop. Okay, so I want to make sure that we have that together. Otherwise, you'll be shocked about the craziness that you may be seeing in the behavior. You know, there may be some error somewhere, but it's going to become obvious when we start testing the system. Right now, there are no testing going on. Okay, we just fixing the most important places aspect of the system. Lastly, we'll come here. We're going to replace this. There's something that we need to update. We're going to update this here. Okay, basically we are just removing this and some unnecessary cases. So I'm going to remove this. Okay, and let's trace these errors now. Oh, so we haven't actually fixed this. We need to continue from here, right? So we need to complete that part. Okay, to complete this part, now we're going to have the assistant message. Okay, assistant message is going to be looking like this, and that is after you've called the assistant, it's going to return a response, and that response, which is the final output, that is what you're going to be providing as the what's it called, content, and you just add that message to the conversation history. You get? So, and but if you have any mess error, you can print it out. Okay, and you can define it to be much more cleaner than this. So I'm gonna do this. Have error message, chat message, the ID, the role, and the content, okay, of that message. So you're just trying to figure out what kind of message is this, all right, and you apply that correctly, and then you add it as well onto the chat interface so that all can easily see it. So this completes that part. This refresh case is no longer necessary. We're going to remove it. So we're going to look for where else do we have an error. We have an error somewhere in this. So how you easily detect error by finding key. So it's saying that cannot find extract valid from response. So something is wrong here. I thought we created this. Okay, yeah, there's only one extract. Okay, because when I check all the extract here, so it created this. There was no way we're going to skip this. We wrote it down. I just don't know why it seems to be missing. I may have removed it. I don't know, but because it is missing, I'm gonna just add it and shame the devil. I'm just gonna add it somewhere, maybe below here. Call it extract valid. So this is what it simply is. Take verdict, the reasoning string. The verdict is coming from the judge response. And this is the output, what we expect that it should return back, you know, to the, calling function, and it should uppercase the judge, verdict, and look for keywords such as not guilty. And if it when you find it, then the case means that it's a not guilty case, in a not guilty case. But if you can find a guilty situation, then it should be what? Guilty state. So this is how, and this is what it returns at the end of the day. So that is how the judge, comes to make their reasoning, right? So that seems to be a lot. So let's try something. Let's ask, how many cases do I have? AI services not configured. Please check API key. So I'm going to quickly check this. So I've checked that and it's actually present, okay, but just with a little different name. So I'm going to change the name here. The name is actually supposed to be Next Public Open Router API key, right? So that's the correct name. I'm going to do this again. How many cases do I have? Let's refresh that first. So something went wrong and we have to fix this. Okay, so I just figured out that the problem that majorly happening here is coming from the fact that we are actually interacting with with OpenAI, not OpenRouter. That needs to change. Okay, so we need to look for where we had the whole OpenAI thing, okay, of chat completion. Let's find that in our file. I'm going to do find. So this endpoint is pointing to the wrong direction, right? So we need to update that. In order to update that, I'm going to change this. This pointing to open router now. Great. And you can just be and literally just update the entire thing here. Basically it's the same thing, and that is one you can also this when you need to change this message, we need to make it much better than this, specific to open router. Great, so this should work. Well, let's test it out. That's the only way we know for sure. I'm going to copy this message. No, this message here. Right, I'm going to come paste it here and send. Okay, this one now is a new issue. We need to fix this as well. All right, so we are having another issue, and we figure out that it's coming from how formatting response are handled, begin serialization and all of those things. How they are handled is the problem that we're facing. And I'm gonna do this, so first of all, this particular function is part of the reasons why it's misbehaving. So the problem is coming from here, not directly here, but how it is being utilized. You see, we have this function called format2. Okay, format2 response, was nowhere. I didn't do anything very, this is too simple, okay, and it's not robust enough to handle the complex nature of the LLM output. So we need to improve that. Okay, so how do we improve that? We do the following. Okay, I'm going to remove this first because it's not going to help us. I'm going to create a helper function inside that inside this format to response. First helper function is format case status, which takes in a status and returns a string. So the status is passed in through this record-based system where pending, it gives an emojified format of it. So just emojifying them, okay? And then when we pass in the status, which should be in uppercase, it will return the appropriate emojified version that will help us to format case status. All right. Also need another one for formatting verdict type. Verdict type, we want to imagify it as well. So if we're passing probably a string or a number, we're passing a number, string basically. Okay. Um, we'll pass 0 is guilty, and you can see this modified version. And in case we're passing actual letters as well, it's also going to emojify them. Okay, and then at the end of the day, this type is converted to a string. Okay, or just return that string, return that type in case something is not well, is not catching these things correctly. Okay, so those are some helper functions. Also want to provide another helper function here. This for formatting address, in just formatting the Ethereum address to be better, making sure that it is truncated in the middle. All right, it's just similar to how all these are truncated. You see the way it's formatted. That is what will happen with this function as well. And then we need to handle some errors. Okay, in case we have an error, so we say 2. If there is 2 output, part of the things that we pass in here unknown, and type of it is an object, and type, type of the 2 output is an object, and error is in the output. Then you should return error output. So you just format the error message correctly. And then we also have we also have some cases that we need to switch around. Okay, so we need to do some interesting switchings here. So format based on a tool type. So passing a tool name. So we're doing case by case, and I'm going to bring in the first case. The first case is this. So the first case is if it's get connected wallet, you're calling on that tool. Then the output should be connected, address, user, if it is owner, and then the contract address. These are the records that we are expecting as the output. If there is no output dot connected, then you should return wallet not connected. Please connect your wallet to Rumblecode to use Rumblecode features. Okay, so this is very important because Rumblecode depends on wallet connections, and then it should return this string. All right, this is a string you should return. Okay, return. Okay, so you should return wallet connected status, and then those information such as role and the address and the contract record. All right, so this is the first case for formatting these two based on the kind of case that the kind of tool that we're working with. We have another case here. What if you're filing a case Okay, if you're filing a case, what should happen? So this is how we expect the output to be. Okay, as success message, this title, transaction hash, which is basically the evidence and the next step. All right, and want to say check if it's a success output. If it's not a success output, you produce this error. Otherwise, you return the information. Okay, return this information in case title filed successfully, and then the transaction hash, and then the next step that needs to be done. All right, and also have another one for get case, for getting a specific case. And these are the things that we expect to return. And of course, you can format it better by going to that courtroom. You can find a way of revamping the dynamics between this courtroom context, and this courtroom MCP tool to have a dynamic way of anticipating the response structure here, okay, and fabricating it on this structure as well, so that you won't have to create this thing 2 times. So right now it looks like we're doing something 2 times. You understand that? So you won't have to do this 2 times. Just use that structure that you've already created in the MCP2. But for the sake of cleanliness, or should I say cleanliness, for the sake of this particular build, let's just follow this simple approach. Makes our work a lot easier. So this is the output of the case. The case output, you want to return this information. Okay, the case title, all that. That is what means when a case is filed successfully. And we have user cases. Okay, this is another case where this case is long, so I'm gonna try and break it down. All right, so in this case here, which is get user cases, takes in this is output structure that we expect to be coming into, that we are framing. Okay, cases are in arrays and include ID, title, and status. Okay, ensure that we just do some checks, guardrails, okay, to make sure that the case is present. All right, if the case is present, then we want to group cases by status as the first step. So we're grouping it by status, either pending, trial, completed, and appealed. Okay, and want to format the case. So let's format that case in formatted number of cases filed by you, and then you want to look for the completed cases. So this is finding all cases that have been completed, and you want to also find the cases that are on trial. Okay, and you want to find the cases that are on appeal. All right, and lastly, you want to find the cases that are still pending. Okay, then you want to return the formatted trim. So you want to return a trimmed version of it. Okay, so this is another case. I think I'm just going to close this so that you can see correctly. And we have a very short case. This is for checking the total number of cases. Okay. And we also have a start trial case. Right. So this is how the case is. This is how we structure the output. So the output is going to be different for each one of those cases, and they are basically mirroring the way these outputs they are for each one of these cases, as well. And you see that the output is going to always be different, and you can see how one of them will fall. So it's mirroring this, and that is one of the reasons why I say that if you can find a way of dynamically mirroring that straight up here instead of having to recreate it here, that would be fantastic, modification that you can do. Okay, so at the end of the day, we want to return these this steps. Okay, want to return the information. So that's for starting trial, and the recording of trial as well is okay. We want to record a trial, and to record a trial, this is if I compare that with recording trial here, you can find that this is how it is. This is the format, the case ID, the case verdict, and the next step. What we have here is the the success, the case verdict, and the next step, including a hash. So basically, this one's contain some extra information. Okay, you want to also get verdict. There's also a case for getting verdict. So I'm gonna do get verdict. You structure it this way. This is how the output should be coming. Okay, and we format the verdict. We're actually using this format verdict function that we created above here. These format cases, we used it using format verdict. We also formatted address, so we've used all of those functions. So, and then when the verdict is formatted, it will tell you the decision, the recorded timestamp, and the final, if it is, if you can appeal it or you cannot appeal it. All right, if it's yes, you can appeal it. If it's no, you cannot appeal it. All right, so that is what, and then the reasoning, this is what the LLM is making as a decision. So that is to get verdict. We also need to check if it has a verdict. Okay, so it has a verdict. This is how to structure it. Output a verdict, has verdict, case, message, and then so if it has a verdict, you see check mark. Otherwise, you put this pending status icon. Okay, so what else we also have? So this function is very lengthy, and it's supposed to be there to make it's necessary to format so that our stuff will look a lot better. Well, I'm going to test it against two options. Okay, but because this is very lengthy, okay, very lengthy, and there's a reason why I actually did it this way initially, because there were some issues in how the records are being displayed. So I'm going to come here, if it's at P, because we don't need to be doing this for every case. It's kind of defeat the purpose of dynamism. Okay, you understand what I mean? It does not help in our dynamic flow. All right, so what I'm just going to do what I'm going to do right now is we're going to just give it a default instead of trying to put all these cases together. All right. I'm just going to, instead of switching amongst them all, I'm just going to give this a default value. And the default one is going to be the get users cases. So I'm going to just look for that case. All right. I'm going to comment this out. Look for this. All right. Let me try and close this once. Okay. And then let's give this a default. Sorry, probably should be inside here. So the default formatting. Okay. So this is default formatting. Default formatting should just look at the tool and check for things like success, unify the icon, and then just produce, the output with this bit replacer functioning. These formatting, we're gonna just comment them out for now. Okay, so let's try this. It almost seems to make sense, but I don't think it's gonna be the best way of doing this. Can you get me my cases? Something went wrong with it, so it's still not interpreting it correctly. Let's go back and continue what we were doing and ignore the hiccup. Let's follow through with what we're doing. Okay, so then we have one more case, which is, no, we have get case where get system owner, and then grab the output. This is how the output is. Just present it as the kingdom, the system owner, and then you have a default tool, okay, or formatting a message in case it doesn't fall into any one of those categories. So let's save that and see how it looks. Okay, I'm gonna refresh this. Definitely there's something wrong with this, but let's type in. Yeah, so responses are returning correctly now, which is fantastic. Understand? Fantastic. But there's something wrong with this initial message. Okay, so I think the problem, let's come back here. Probably how I may have, meddled with this. I don't know if I had meddled it wrongly, but for some reason it's not obeying. If I save this, not obeying. Okay, so the formatting needs to be gotten correctly. I'm going to get the initial formatting in, try and see if it will correct itself. Save it. You're seeing what I'm saying right now. So it has to be in this formatting for some reason. I don't know why. If I meddle with it, it becomes problematic. So this is how it should be. Okay, so at this point, our formatting is going well. Meanwhile, all these ones worked correctly. So this is a lot. And let's try and create some cases. So let's refresh this again. Let's say, can you file in 3 random cases from the top most debated social issues of our time. And then let's see. Yep, it's calling to confirm that, confirm, confirm. You can see it added three cases successfully. Understand that? So the three cases have been filed. One is about climate change, Another is about artificial intelligence, regulation debate, and also on healthcare access and universal coverage. Let's think about artificial intelligence regulation. No, we haven't tested that simulation thing, so let us test it out and see that it is working. If I click on that, you see the way it call to simulate this blockchain courtroom process. You see, it is required that I start a trial. So I'm going to confirm that and see trial started, and you can see the judge already processing the file, and you can see the progress bar just moving on, changing. See how all these things are changing. You can see processing here. You can see how they are debating the issue in the court. So this is what is going on. And at the end of the day, look at how the number of messages just increasing at real time. So at the end of the day, the verdict is going to be drawn, and then the judge is going to what? I'll say, okay, this is how it's going to be, and then trigger the case, and we move. Okay, the judge is about to render a verdict. Okay, not guilty, and you can see that triggers its function, and verdict is not guilty. The case is completed. Okay, so what about we argue this one and start it, but then in the process, I will come and cancel the case, and let's see how it goes. So this is what is going on here now. This is the middle of a case. I'm going to click this cancel, and you can see that simulation has been aborted. You get that? And this normally should update in its own, but if you refresh, you can see that that case is now on trial. So if a case is already on trial and you click on simulate, it doesn't need to trigger that wallet anymore, and that to start trial anymore. It just moves on. You get that? So this is important, this. So if I say how many of my cases are completed, say one case completed, and it also gives you some other info about the case. So you say, can you provide me with the verdict on the case that was completed? You see, now I don't need to actually give it the ID because it's an LLM and it's intelligent to be able to figure out and provide me that information, right? So now, okay, so it has an issue with that. So if I look for that case 5, can I say, can you give me the verdict on case 5? Really don't know why it's triggering this now. Okay. So what is happening here is probably making a mistake. This is what they call model hallucination. Okay. when a model isn't smart enough, it can be an issue. Okay. So remember, I told you that we had two ways we can render verdicts. I just tested now the two ways. First one is during the simulation itself, the verdict is rendered at the end of that simulation. But the second one is if a case is already on trial and you want to render a verdict on that case, you can just, you know, you know, find that case and ask for a verdict to be given, on that case. Okay, so this model, since it's not smart enough, it just went on and asked verdict. Meanwhile, I was only asking for the verdict on that case. So let's um let's say we refresh this and let's put this again and let's see if it's a lot smarter now. All right, you can see that it's what this has to do with smartness. It has to be with context, retainers, memory, and all of that. It should have been able to do what I just wanted it to do in the first time without having to, you know, um, trigger the 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 verdict issuance on a different case that has nothing to do with it. I was talking about case 5 and it went to one and render verdict on case 3. These are audio the LLM hallucination and problem that have to do with it. And this often comes because the model is not very smart enough. So models that are very smart and capable are the ones that you should use on production. And this is okay since we are only dealing with the testing and development and all that, MVP and all that. So it's okay. But if you're going to be, bringing this model, if you want it to be on production, just imagine you're doing a real um, project like this that is dependent on the accuracy of a model and its behavior like this. This is going to be a huge letdown. Yeah. So, but it doesn't have to be like that if you're using. So I would recommend use DeepSeek since it's cheaper. You understand that I'm very resilient, very powerful as well. It's not free, but it's so much cheaper compared to models like, from OpenAI and Anthropic. Even Grok is also expensive, so use those ones and you can see. So at the end of the day, this is working. How about let's simulate one more and then we'll try and do an appeal on it and see how it goes. Okay, so it actually rendered guilty this time. That is pretty cool. So I'm going to confirm this. Okay. All right, so that has been rendered as guilty. That's cool. But for this case of this IP infringement claim, I want to appeal it. It's been completed. So let's say, can you appeal this case? You see, make sure that selection is very important because if something is also selected, I think it can confuse the AI on which particular one to do, which is still a function of low intelligence. But I'm selecting this case 3 and I'm also asking from what for case 3, can you appeal this case? You can see and it's been appealed. You can see that down below here. And let's see if we want to start another simulation process for that. Will it allow? You can see that we can actually re-simulate it and all of those things. But at this point, I'm just not going to be doing that anymore. So this is pretty fantastic. We've tested a whole lot of things. There's, theater mode, which just removes that whole thing. There's quick references, which you can use to do quick things. You can say, view my cases. And you can see here below, view all my cases. And of course, this one is producing a little bit of an error, but you cannot actually, you know, we've already done something like this. You understand that? So this is just some model hallucination. We've already listed all our cases before by just writing similar prompts. So the major issue that we found about this project is that it has a prompt issue. Prompt issue. I mean an LLM issue, an LLM intelligence issue. Okay. So this little error that you keep seeing here is coming from a module that actually, a module that I actually was using, which is this module that keep producing an error, MetaMask module basically. If you come here, you can see this MetaMask SDK analytics. It's just annoying. Okay. So, and this one, you can clearly see that the second error is coming from an interaction with what is it called, open router. So that means it's coming from the LLM interaction itself. As you can see that this message is coming from this endpoint. So we don't need to debate that issue much. And there you have it, guys. Rumble Court from start to finish. We've covered a lot of grounds today. Autonomous AI agents with distinct personalities, debating in real time, blockchain integration for transparent record keeping, and a sleek Next.js interface that brings it all together. But what really excites me about this project is its potential. This isn't just for lawyers, it's for anyone who wants to make better decisions by seeing multiple perspectives, testing arguments before the matter, and building the habit of balanced thinking. So if you want to try it out, I'll drop the GitHub repo link in the description section below. And if you're inspired to build your own multi-agent system, or want to see more AI blockchain fused projects, hit that like and subscribe button and smash that notification bell. And let me know in the comment section what you like to see next in my upcoming tutorial. The code is open source, contributions are welcome, and I would love to hear what use cases you come up with for RoboCut. Thanks for watching, and I will see you in the next one. Bye-bye.